All right. PyTorch. We're going to do PyTorch. Happy Monday, everyone. We're going to be doing PyTorch. We're going to learn the basics of PyTorch. The last few streams, the last few weeks, we did algorithmic trading using PyTorch and NumPy and scikit-learn and some other frameworks. PyTorch is a really powerful framework. In fact, it's probably it's the framework that wins all the frameworks, from building AI applications, things like large language models, the impressive AI. You've used ChatGPT before, you've used PyTorch. It's where things are based on. PyTorch is actually a rather advanced and involved framework, which includes a lot of tools and utility. It's got a lot into it. And the more you know it, the more you can take advantage of it. Otherwise, you'll do things like I did, where I was not aware of all the different amazing things PyTorch can do, what it comes in, batteries included, right? It's got everything. And so at moments when I could have used the framework, instead I used my knowledge of machine learning to build it myself, when I should have just been using the framework. I could have been doing that all along. You never knew. So the plan today is we're going to be walking through PyTorch and the introductions, the quick starts, the tutorials. We'll see how far we get. We'll just give it a shot. We'll see if we can learn some new things. I think we will, because I was walking through a little bit of it, and there's some things that I didn't know that you could do. For example, the data loader. You could use the data loader, and my data was text-based data. And I was assuming that, if you're going to be importing data into a model, it needs to be vectorized. It needs to be pre-vectorized. Apparently, if you use the data loader or data sets, it gives you the capability to leverage raw data, non-vectorized, so you can sort of import and just use that data as the raw data source. Hey, Quantified Quantum, how's it going? Welcome on in. We just got started. We are actively looking into PyTorch. Some of the things that hey, good to see you here. Good to see you. Happy Monday. Hope you had a good weekend. I did. It was a pretty good weekend. It was a productive weekend. I wanted to relax and play, maybe play some more video games and, just sit down for a bit. It was busy. It was a busy weekend. Though I was thinking that over the weekend, I needed to brush up a little bit more on PyTorch. I really want to do this because there's a lot of capabilities in PyTorch. It has a lot of stuff, and I'm really excited. So let's jump into it. So we're going to be using the quick start. This is on the PyTorch website. So if you want to follow along, you can do that as well. We're just going to be copying and pasting and reading through the docs and see how things go. So PyTorch has two primitives when working the data. You've got a data loader and a data set. They're two different things. Hey, Mohammed. Hey, how's it going? Welcome on in. Happy Monday. We're working on our PyTorch basics. We did some algorithmic trading with AI and Python, and we built a model that did a pretty good job. I think it did a pretty good job with the benchmarks. So yeah, you heard of Express.js README spam. Oh, yeah. Maybe. Thank you for the likes, you guys. What's up, babe? How's it going? Danny Gamey Gop 7580. How's it going? Happy to see you in here. The Express.js. Wait, hold on a sec. Just that. Express.js README spam. Is this when you're committing? I heard that a lot of people are doing PR spams. Yeah, PR spams. Yeah. So there. Yeah. Apparently, you can just open a pull request to any repository and then put your name on it, and then it looks like you've contributed to the repository, when in fact you really haven't. You just it's a bit ridiculous. You need to be careful. You got to be careful with this. Why and how girls do skincare daily? Oh, most evil 2304. Well, it's because I guess it's just hygiene, right? It's hygiene. It's hygiene, right? Most evil, you got to do hygiene. Yep, that's open source contributing thing. It is. I know. It's just, I heard about this, and all you have to do is just make a PR, make a small little change in a PR, and then boom, your user is now associated with that repository that's open source. You're an open source contributor. That's the way to do it. So we can see your comments by, only without top messages. Oh yeah. Gotcha. Okay. Wait, what does that mean? What do you mean? Wait. We can see your comments, but only without top messages filter. Okay. Is it because of my Reddit stuff here? I think we're fine, right? I think we're fine. Let me know if I exposed anything accidentally. It feels like we're looking good. I got all nervous there for a second. It started from an Indian tutorial. Now they removed that part. They removed it from the tutorial. It started from a YouTube channel apparently called Apna College. Oh, really? So Opna College was like, hey, did you know that if you wanted to contribute to open source, you could just simply open a PR against your favorite repository? Oh, I'm talking about Instagram. Oh, okay. I don't do you see it up there? What that's Reddit. Oh, what's Reddit? What do you mean what's Reddit? What do you mean what's Reddit? How do you I don't know what Reddit is? What about React.js? It's the same thing with React, right? Isn't it Express.js, React.js? You can do it with any open source. Any of the open sources, you can do it. Apparently. That's all you got to do if you want to get yourself, hey, how's it going, Mohammed? How's it going? Good to see you, Mohammed Saul. Welcome in. Happy Monday. Good to see you. Good to see you. Okay, let's see here. Hey, how's it going, Harsh? Welcome on in, Harsh. Happy Monday. Thank you for the likes, you guys. We're going to be going through PyTorch today. We're going through PyTorch. We're going to be going through the basics because last 2 weeks we did algorithmic trading with AI. We used PyTorch, though I didn't use all of it because we could use a lot more of PyTorch. Then I only use YouTube. Okay, cool. Danny Gamey Gop. That's actually a really good idea. That's a really good idea. YouTube's fantastic. Can you please create a video on Llama Index? Agentic RAG cause LangChain is too overhyped. Oh, Llama Index. Actually, let's check that out real quick. Let me add that to our. Actually, you know what? Let's just add that over here. Let's add that on our future streaming ideas. Hold on here, on our Discord channel, future streaming ideas. We will be doing. Let's see here. Let's talk about. It's called. What did you call it? Oh, Llama Index. That's right. Llama Index Agentic Retrieval Augmented Generation RAG. The versus instead of I think that's it rather than LangChain because it's a framework there, right? We're just talking about frameworks here. Is that a word? No, it's okay. Perfect. Future streams. Boom. All right, answered. Oh yeah, it looks like they're reloading the page at Instagram. Oh, gotcha. What do you think about TensorFlow? Oh, Harsh, TensorFlow. Our TensorFlow is fine. It's Google's framework, right? And Google is the leading, I believe, they are the leading AI business out there. Now, you've heard of like OpenAI and Anthropic and these other. I think Google is a step ahead. All their engineers are what spawned the capabilities of OpenAI. And even Quantified Quantum mentioned here an article that was released in 2017 here on our Discord. 2017, where was that here? It was around here somewhere. You put a link. You're like, in 2017, they released, right here, the Transformer paper by Google in 2017. So Google's the one that got started with all this. They got it all started. It's all from Google. It's all Google's capabilities that they were achieving. Dude, I want to join your Discord. You do? Okay, Harsh. But their graphic optimization is total BS. Is it? Oh, with the shorts, the YouTube shorts. Is that what it's going? Cromer12, how's it going, Steven? Can you see my comments now? Yes, we can see your comments now. And definitely can see your comments now. Attention is all you need. You got it. You got it, Snehan. You got it. Thank you for the likes, you guys. Yeah, Cromer12 could see your comments. If they weren't showing up before, they are now. They're definitely showing up now. So, dude, I want your Discord. Okay, Harsh. Hey, don't die, 88. Welcome on in. Good morning, Steven. Good to see you. Happy to have you in here. We're going to be doing PyTorch today. We're doing PyTorch. Hey, remember me? Cromer? Yes, I do. I definitely do. Hi, apologist. Hey, yepitologist. SAQ 3000, welcome on in. How are you doing? Good to see you in here. Happy Monday. How much new vocabulary? My brain didn't catch. I know, right? There's a lot of vocabulary out there, but most of the vocabulary is just the same word for array. It's just the same word for array for the most part. It's just the same word for array. So we've got, so someone was mentioning about a Discord. Let's grab the Discord link real quick because you were asking about it. You were asking about it, Harsh. Here, copy here. So at Harsh, Discord link. There you go. Let's grab you the Discord link. Boom. Discord link for you, Harsh. There you go. I was talking about, so TensorFlow versus PyTorch, right? TensorFlow has been around, I believe, just as long. So TensorFlow is from Google. PyTorch is from Facebook Meta. And for whatever reason, it caught on more. I don't know why, but PyTorch has kind of taken a lead in, I guess, popularity. I don't know why. I think TensorFlow is perfectly fine. And even it's got Keras, which is a higher level API on top of TensorFlow that makes it even easier to use. So I don't know why it hasn't taken on. But I guess PyTorch is the way it is. PyTorch is what we're doing. So that's the plan. Your knowledge is invaluable. And you are helping hundreds of people. What a great guy. Thank you, Don't Die 88. That's the plan. Thank you for everything. Happy to help. Happy to help. Steven, wait. What do you mean, Steven? What do you mean, Steven? So I learned PyTorch 3 years ago. Okay. It took me 2 months. Spent 9 hours a day. That's a lot. That's a lot, Chromer 12. I mean, it really depends. So are you already familiar with AI and machine learning concepts? Have you written your own feed-forward neural network? Things like that. PyTorch, I believe, would probably be pretty easy to learn because I was able to use it perfectly fine in multiple projects without even having to learn the framework itself. I just feel like I'm missing some of the components of PyTorch itself. It's got a lot of capabilities baked into it, and I'm often finding myself using things like NumPy when PyTorch can do everything NumPy can already do. So I'm using multiple libraries, and I don't even need to. You don't need to use multiple libraries. Hey, how's it going, Risha? Good to see you, Risha. Welcome on in. Quantities. You got it. Quantities. All right. So here, let's jump into it. All right, so let's see here. We're going to work with PyTorch. We're going to follow the examples. Okay, PyTorch has data loader and data set primitives. And when I was reading this, I was looking at this PyTorch or PyTorch Vision. This sounds like, image data, right? Image data. And there's a data set. I'm like, why not have just a universal data set? Why not have just a universal data set that you can use for anything? Well, it turns out the data sets are specifically, what are we doing today? Risha, so we're going to go through PyTorch. We're going to go through the basics so we understand some of the things that we are missing. Typically, when I write my own AI models, I will use PyTorch or write my own from scratch, completely from scratch. And so I want to get better at the frameworks. And even when I use PyTorch, I'm not fully using it. I want to use more of it. So we're going to start off with the basics today. If no one's done AI before, then this might be generally an okay introduction to AI for you guys. It might be a good introduction. Must learn before diving into PyTorch. Hexadecimal 1591. You don't really need to. I would say just jump straight into it and then just try it out. Just give it a shot. Just start using it immediately. And then just by using it, you'll start learning things. And that's like the best way to go about it. So don't worry about the prerequisites. And thank you for the likes, you guys. Python, you got it, Mohammed. I have made 3 machine learning models, but I want to learn something more involving any recommendations. All right, Harsh. Definitely check out PyTorch if you haven't yet. The quants. I know SAQ 3000, the quants. That's what we were doing the past few weeks. We were building our own AI deep learning using PyTorch AI model to profit from. Thanks, dude. Happy to help hexadecimal. All right, let's get into it. Quantum capability. Quantum SAQ 3000. I like the way you do with your words there. I like your words. All right, so we've got Torch neural network, NN neural network. Then we got a data loader, which I guess is a universal data loader. I'm guessing for batching and other ways to sort of take data and then put it into the model for training purposes. That's my guess. And the data sets is based on the raw data, pre-vectorized. This is my assumption. This is my presumption. What is your processor model? JB989889. What is your processor model? We're doing a Mac. It's a M processor. It's Apple's M processor. We get an M processor. So it's got GPUs baked into it, right? It's got everything all in one. It's a system on a chip. It's a GPU, audio, video, everything all in one. It's great. All right, so the Torch Vision Dataset module contains dataset object for many real-world vision tasks like Sifra, Coco. This tutorial will use Fashion MNIST. Now, when I read this, I didn't know there was multiple kinds of MNIST. I thought MNIST was just, the handwritten characters for optical character recognition data set for training an AI for recognizing handwritten numbers. But apparently, there's a fashion MNIST. Whoever thought there was a fashion MNIST? I didn't think there was. Apparently, it's a bunch of clothes, right? Some clothes, items, some clothing articles, and you can use it to train a model. You can use it to train them all. Don't you think PyTorch has to improve its documentation? Yeah, because PyTorch is complex. It's complex. It's involved. There's a lot to PyTorch. There's a lot to it. So I haven't even fully used all of PyTorch, right? I'm just touching the surface. When I use PyTorch, we're just touching the surface. Let's go deeper. Neural processing unit. We're just basically going to be using GPU accelerators with our Mac Silicon. I can't find other words related to quantum. you want to do some play on words? Can I train it on a Pentium dual core processor? Notorious 3875. You could. You absolutely could. This will definitely support that. It will absolutely support it. If so, you want. You forgot? Oh no, you forgot SAQ 3000. Holy, that's ancient Pentium dual core, and not that ancient, but still, it is. It's way from a long time ago. It should still work though, because all you're doing is matrix multiplications and some math. That's it. You're not doing anything super special, so you can absolutely do it. It will work. That's kind of the thing. I was like, wouldn't it be great to go back in time and then work on these, older computer systems and then evolve AI even back on those hardwares using the modern AI algorithms? I think that'd be a lot of fun. Things to remember in PyTorch: data loader, model define, optimizer, training loop, eval. Remember to use torch.inference mode. Thank you for the likes, you guys. Well, eval, I didn't even know about inference mode. All right, Chromer 12's got us some ideas here. While eval, it's modern technique that it's more modern. It's a modern technique. Really, inference mode. Oh, inference mode. Okay. That sounds a lot better, because typically you want to say like without grads and then model.eval, right? Or torch.eval, because that will prevent when it turns off the dropout, it turns off the gradients, and it turns out the output storage, right? It turns off those things, so that way it makes inference faster. I'm using OPEC XO Green Notebook. Search it up. It's really old. Is it? I didn't even know what that is. I have no idea what that is. What is that? Quantum is ratatouille. Quantatouille. Valid word. You're trying SAQ 3000. I see what you're doing there. You're running on an i5 4th Gen U series on integrated graphics. Hey, Quantified Quantum, that's more than enough. You know what? I was running on that even for so long, and you can achieve as much as you need to with that. Hey, and you know what? If you need to achieve more, you could just rent a GPU for a few pennies per hour. You could rent a GPU using these cloud providers. What are your thoughts on OpenCV? Like, is it worthwhile? Let me double check. What was OpenCV again? Let's see. I know OpenCV. What is that? OpenCV, computer vision library. Oh, world's biggest computer vision library. All right. So you've got things like Ultralytics that have their own, right? So you've got Ultralytics. They have their own YOLO. It's called YOLO. Here we go. So you got YOLO as another computer vision model. So you got YOLO, and then you've got OpenCV. I mean, I would just use PyTorch. That's the only thing I know. I don't know about these other things. I'm not familiar with them. OpenCV is the world's biggest computer vision library. It seems like that. I don't know about that. Not with PyTorch around, you guys. It contains 25,000 algorithms operated by nonprofit. Oh, so it's got a whole bunch of stuff ready to go for you. All right. So this might be an easier to use computer vision framework. It seems like it's an easier to use one. Although it says there's a coupon code. Does this cost money? And I'm getting advertisements. I don't know about this. I don't know about it. If I'm getting advertisements, I'm suspicious. I'm a little suspicious about it. Check out, wait, hold on 1 second. Let me get back over to here. Let me get back to the tutorial real quick. I want to run through the tutorial on this. We'll do some copy and paste. Here. Let's open this up real. Let's paste that in. There we go. Test.py. Let's do that. All right, test.py. Let's pop this open. Python test, which should just be a no-op, right? It'll be a no-op. Perfect. There we go. Hold on 1 second. Let's jump back in here. We got some of the text, chat messages. Check out Zen Browser. Oh, Quantify Quantum. What is Zen Browser? Let's check it out real quick. Zen Browser. What is this? Zen Browser. It's got the same colors as Anthropic. Welcome to a calmer internet. Beautified design, privacy focused, packaged with features that care about your experience, not your data. Oh, okay. Okay, so it's basically Chromium, though with privacy as the top item. Privacy is the top item. Okay. Compact, easy. Okay. It looks great. I've seen some of our developers at our company use this, and I didn't know what it was, but Zen Browser, there you go. Very nice. Good recommendation, Quantified Quantum. Thank you. Thank you, Quantified Quantum. All right, let's jump in here. How do you daily practice discipline for months and only do 30-day hardly? It's big for me. Tips, bro. Hey, it's Dina Gima Gop. Wait. Donnie Gami Gop. Donnie Gami Gop. Wait, how do you do it? You just got to do it every day. That's what the thing is. You just got just a little bit every day. Just a little bit. Just practice a little bit every day. What is the difference between TensorFlow and PyTorch? All right, Nikki. Nikki Lamau, the difference, they're basically the same. They have the same algorithms. They both have hardware accelerators. They both support TPUs and GPUs and CPUs. They support all the hardware. The AMD and NVIDIA. They support Apple Silicon. They both support the same thing. They all have the same algorithms. They're basically, the only difference is PyTorch is going to give you a little bit more granular capabilities. So that way, I guess, you know why it's actually helpful for research assistants as well, because they're familiar with their own algorithms and other libraries. Also, it's more Pythonic. So it's more Python focused. So if you want to use Python, which is the premier language for data science and AI, then PyTorch is going to be your better friend. PyTorch is a little bit better. TensorFlow has Keras, though it's not necessarily Pythonic, but it is easier to use. Surprisingly, you wouldn't know. I'd say Keras is a lot easier to use with TensorFlow, and it has the same capabilities. Thank you for the likes, you guys. So it's got the same thing. It's just that PyTorch is a little more friendly to other libraries. You could do the same thing with Keras, though. Although Keras is a little bit higher level, PyTorch is lower level. So you get more access to do more things, though you need to know what you're doing more. With Keras, you don't need to know as much. You just don't need to know as much. So yeah, TensorFlow and Keras, easier. PyTorch, more advanced. There you go. But they do the same thing, exactly the same thing at the end of the day. Exactly the same thing. Thank you for the likes, you guys. Use Google Notebook or Kaggle Notebook. They offer free GPUs and model training. Oh, really? That's interesting to know. Do you think you will be ready with your trading AI for the Q4 releases? Oh, Torva Mesor. So we wrapped up last week with our algorithmic training with our AI. So it does a good job. We tested it. It looks good. It's got good results. And then even on our Discord, someone created a notebook that did some testing against live market data. And they did some testing on live market data. It works out really nice. So where was it? Was it here? Free resources. Someone here. Here you go. Here's a Colak notebook from Alan Barrett. Thank you. They created a notebook that shows how you could actually start using it to profit. There's one thing, though. There's one thing in here that I did notice that needs to change. The data is based on, it's got to be recent. It's based on recent information. So the moment the news breaks, the moment that a news article comes out is the moment that you need to trigger this model. This right here is, as you can see here, let me zoom in, is based on a 300-second sleep, which is 5 minutes. So you got to do something. You could use this notebook and profit from it. The only thing is the AI model, which is included for free, pre-trained and ready to go. If you want to use it, you can absolutely use it to profit. And you need to change this Colab notebook. You need to change the Colab notebook to instead do it based on the moment a news article is released. You got to be right on it because that's where the AI model was trained. It was trained on the moments the news articles released versus a sleep. So that's the only thing I would change. Everything else looks good. Steven, wait, hold on. Let me scroll up to some of those chat messages here. So I'm running out of the chat messages real quick here. Okay, blah, blah, blah. Google Colab. Steven, I forgot to say, week's news. German government has allowed to use AI as worker and AI got pregnant. Wait, it's not a joke. Wait, what? Oh, you're really? All right. So I'm guessing that someone set up a teammate, right? A teammate, an AI teammate. And the AI was running through probably a non-deterministic output. It was using just common standard text in, text out. And then the AI claimed it was pregnant and couldn't work anymore. Is that what happened? I'm not sure. That's kind of interesting because the whole point of AI is that it can work forever, tirelessly, and without any problems, without any other problems. That's the idea behind it. Let's see. Wait, quantum searching browser is better. Oh, Xing browser is better. More bare bones. You heard about it. I have not heard about this one myself. Zen is from the same devs who created Arc browser. Oh, really? So, Mohammed, so I remember Arc browser. It got really popular at my company for a while. A lot of developers were using Arc browser. And then apparently they stopped maintaining Arc browser, or they sold it, right? They sold Arc browser. Something like that happened. And now it sounds like Zen browser is the next version of that, right? The people who build it. It's Firefox bases. You got it. It's Firefox based. Oh, got it. Okay. So Firefox, not Chromium. Who would know? Who's in the back? Nah, just kidding. Oh wait, red hair Gildarts. Red hair Gildarts. You freaked. You scared me there for a second. What are you doing? I'm gonna use ChatGPT language. Okay. Mato Nati. How's it going? I know theory, but without copying from somewhere, how can I learn coding from scratch to make someone predictable like a least image classification? Oh, it's just practice. All you got to do is practice. That's all you got to do. And you're doing it right. So practice by building a framework or build a project. Build something. Just work on something that will help you learn whatever you're doing. Because as you're building it, you just start remembering things. It just happens over time a little bit. You learn a little bit over time. It's great. I love it. I'm thinking about starting a side project, detection AI, using OpenCV or YOLO V8 PyTorch. So YOLO has V11 now, by the way. YOLO has V11. PyTorch would be separate. So it really depends. It really depends on what you want to do. So all works. I'm actually curious. So if you're thinking about a simple approach for computer vision application, OpenCV and YOLO might be a good starting point. If you're going to go PyTorch, then you have to get everything from scratch. You have to pull all the data. You have to prepare all the data. It'll be a lot of work, but you'll get the best outcome. Cromer12 says, hi, how's it going? Can you do a video on Apple's MLX framework? So is that Apple's Metal? Apple's Metal framework? JB98989. Apple's, so let's check this out. Apple MLX framework. Apple MLX framework. Is this Apple's Metal library? I think it's Apple's Metal library, right? Metal, is it? Or is it something different? What is this? MLX is an array framework designed for efficient and flexible machine learning on Apple Silicon. MLX is an array framework. So it's probably got to be using their Metal API under the hood, right? Is what I'm assuming. Apple Silicon is like NumPy, but works better. Higher level neural network optimizer package. Oh, MLX. So it's like an alternative. Interesting. It's an alternative to PyTorch, it sounds like. This is an alternative to PyTorch. Let's check this out. MLX. Ooh, pretty. Array framework, efficient and flexible. All right, what else we got here? MLX run an Apple platform, supports Metal. That's what I knew it. I knew it supported Metal. I was like, it's got to support Metal, and it does. Look right there. And it's figured as much. Python, C++ bindings, Swift, and C. Okay. So let's take a peek at that real quick. Let's Let's jump over here. Here we go, documentation. All right, let's see. Build, install, usage, quick start guide. Let's check this out here real quick. MLX as MX. Shape, okay. Looks like it basically, evaluate, okay. All right, so yeah, it looks like basically it's a very easy, simple approach to, it's mostly just matrix. It looks like it's advanced, but it doesn't seem that advanced, isn't it? Oh, cool. Okay. Looking good. I'm just running through this really fast just to understand what do we see here. Okay, so it's got a bunch of built-in algorithms ready to go. Easy, nice and simple. Okay, so you basically you can use MLX if you want to build an AI specially tuned to operate on Apple Silicon. So that seems a little restrictive, right? Because wouldn't you want to use something that is universally accessible like PyTorch? Wouldn't you? When PyTorch also supports Metal, I think you'd want to use PyTorch, right? So building projects, do I read documents and try to write scripts instead of using LLM? Yes, you're right. You got it. Read the docs, try it out yourself, learn what works, learn what doesn't work, make the mistakes. Making the mistakes is the part that teaches you. Humans have this thing called negativity bias. It allows you to focus on things that are broken or wrong or that need improvement. It's our greatest technology in the whole world. You never even thought you knew about it. It's negativity bias. It sounds like it's a problem. Well, you know what? It's actually the greatest capability that humans have. It's called negativity bias. You want to use that as much as you can, and if you don't, you're gonna fall back. You're gonna hit your overuse of the chat GPTs to do all the work for you. You're not going to be able to leverage your negativity bias as much, and so you won't learn as much. You need to fail. You have to fail in order to learn. That's how it works. That's how it works. Trial and error is what it's called, and then you learn through turbulation, through trial and error. That's the way to do it. Thank you for the likes, you guys. See, Bing Bang. What do you mean Bing Bang? What do you mean? Oh, Big Bang. Bing Bang Theory. Bro, do you watch I've heard of the Big Bang Theory. Yes, I know what you're talking about. I've seen a few episodes. The Sammy Point. Yeah, I've seen it. I would like to watch it through completely. I haven't seen all of it though. Try to understand neural processing unit compute. Hey, Cromer12, hi, how's it going? You can sell the Apple code for money. That's a good reason to use over a PyTorch. Oh, really? Really? I didn't know about that. That's kind of interesting. I mean, why couldn't you sell the PyTorch though? Why couldn't you? You could sell the Apple code for money, but you couldn't sell the I don't know what that is. I don't know what knowledge did you learn to reach here? Oh, Nicholas Godressy. Good question. Is trial and error, or over many decades, which tells you I've been in the industry for just a smidgen, just for a little. It's just over many years, lots of coding, lots of practice, and lots of errors. Yo, DVR Goat. Yo, Goat, how's it going? What's up? Happy to see you again. Happy to have you here. Welcome. Happy Monday. What are we doing? All right, Cromer12. We're going through very slowly. We're going through the PyTorch introductions because I want to learn some of the things that I missed. Because I can use PyTorch for its core, matrix multiplications and machine learning aspects. I'm missing parts of it because I'm using my own algorithms where I could just be using PyTorch directly. I'm importing other libraries that I don't need to import. PyTorch has everything built in. There's no reason to also import NumPy, for example. You don't need NumPy. PyTorch already has all that built in. So that's what we're trying to do today. Steven, I'm got RTL8720D. And what is this, by the way? I'm trying to make a dutier. Any thoughts? I don't know what that is. I have no idea what that is. What is that? SAQ3000, what are you doing? I don't get it. Hey, thanks. Nikki, hey, thanks for the explanation. What if I wanted to create my own large language model? Do I need to get the whole world data set? Yeah, you kind of do. If you want to train your own LLM, you could do things like what is it called? Distillation. So you could do distillation learning, where you can train a very specific large language model based on a larger model. So you use a larger model to as the inputs and outputs. And then you take those inputs and outputs, and then you pass those on to your own custom large language model, which is smaller. And then you can more quickly have the model that you train have the similar knowledge capabilities without having to do the entire world's data set. If you want it, it's called distillation. If you want to do that way, you can do it. It's called distillation. Nikki Lamau, distillation. You've been a decade in this field, more than one, Nicholas. More than one, Nicholas, is a few decades. YouTube is blocking normal comments also. Why? Oh, is it? So you can see here on my screen, these are the comments I see. You got to be, it might, if it thinks that there's a link in there, sometimes if you have a period, and you've got text after it, it looks like a link and Google will block it. You got to be careful. If it looks like a link, it blocks. You got it. If it looks like a link, it blocks it. Hi, Steven. These days, I'm struggling to find a field and software that suits me. Do you have any advice? Respublic, do what you want to do. Do what makes you happy. Do you want to be a game developer? Does that sound like a lot of fun? It's a lot of work, but also it could bring you the most happiness. It could, because it could bring you the most reward. Do you want to go into finance and do financial, like maybe you want to quant? Do you want to do data analytics? Like you could do big data. There's a whole bunch of things. Maybe you want to be an app developer. You just want to build apps for the mobile devices. You could do that too. You could build apps. There's so many things you can do. Maybe you just want to do DevOps, which I don't know about that one. That one's got more consequences related to it because you need to make sure the infrastructure is always active and alive. So you gotta be careful. Which one do you want to pick? It's all up to you. Which one's gonna be happy? No, if I write torch interface mode line, it blocks. Oh, really? It means it blocks program when we write in comments. Does it? I didn't know. That's probably because of these. Yes. So like when you're writing code, see how there's a period here? Let me zoom in right here. See how there's a period? See how there's like a period right here? There's like a period. Usually in coding, you got to be careful. Sometimes it could trigger. They could trigger the automatic Google moderator, and it'll block things. You got to be careful. Normal comment. Why write print high? Okay, we'll do it, Chromer 12. We'll do it. Obviously, here we go. Print high. Wait, did I put the right H? Is it lowercase? It's a lowercase I. H-I. And we'll use the single quotes like you did. We're not going to use the smart quotes because those obviously don't work. Here we go. PyTorch. Hello, there's a burden of love. There we go. Hi. We did the thing, Chromer 12. Many people don't know that old method, Torch Nograd, has now been replaced by the newer and faster Torch interface mode. I didn't know about that. I was using Nograd, and I was also using eval. Chromer 12, over the past 2 weeks, I've been using the old approach, but we want to use interface mode. Let's learn about interface mode real quick. PyTorch interface mode. Let's do that really quick. Let's take a peek here. Interface mode is not a standard PyTorch term. Oh, isn't it? But it can refer... No, I think Google might be behind because it's so new. Here we go. Interface mode. Grad mode. Context manager enables or disables interface mode. Interface mode is analogous to Nograd and should be used when you're certain... when you are certain your operations will not interact with AutoGrad during the data loading or model evaluation. Compared to Nograd, it removes additional overhead by disabling view tracking and vision counter bumps. It's also more restrictive in that tensors created in this mode cannot be used in computations recorded by AutoGrad. Okay, so basically, when you want to use inference mode, basically when you're saying you're not going to be training the model anymore, when the model is going to freeze the weights and the biases, all the inputs and parameters, no inputs, no dropout, everything's going to be disabled, and it will be faster. It'll be a lot faster, but also it looks like specifically an AutoGrad thing. It looks specific to AutoGrad, which I've not used before. I've just regular Torch. I've done regular Torch before. All right, let's see here. You can do NAN in future. Can you do NAN in future? Okay, Harsh. We will add. I think that's on our future streams. Let's see here. Let's see here really quick. Oh, whoa, we got a thing that popped up there. We don't know what that is. All right. We will do, all right, future stream. We might already have this as a future stream item, but I'm going to write it down anyway. Future stream, we'll do N8N. I'm pretty sure we already have it. N8N, N8N, review, or I don't know. N8N, there we go. Let's just call that. We'll just put it future stream N8N. There we go. Okay. Let's jump back over here. How long do you think it will take me to learn to modify a large language model? I have the medium knowledge. Oh, so Nicholas, if you wanted to, you could just download any large language model now, and then you can modify it and do, what do you call it? Tuning. You could tune it yourself, or is it called fine tuning? It's called fine tuning. You could do fine tuning, and it doesn't take long. So I would recommend doing the GPT OSS or the Llama from Facebook. Those are easier to do your own fine tuning on, I think. Have you ever heard a term and conditions of any company? Me, no. Steven, search for what's Wi-Fi D-author or D... okay, let's try SIQ 3000. Let's find out. What is that? Let's find out real quick. Wi-Fi D-author... authorer or D-authorer. All right, let's try this. What does it got? Wi-Fi D-authorer. What is this? Oh, it's a thing. Kicks devices off of Wi-Fi network. Why would you do this? Why would you want... This is spam beacon frames. This is like a malicious tool. It's a malicious tool. What would you do? You're going to pollute the airspace, the radio waves, with your attack packets. Your attack packets. If you wanted to be malicious, here's a way to do it. And you could use this device probably to disable smart doorbells, right? That record, right? That record connections or video. You could probably destroy any network just by having this malicious device show up and then disable connectivity. You could use this malicious device to disable. Why'd you want me to look this up and tell people about it? Why'd you want me to look that up? Have you ever, let's see, how long, okay, can you show how to make a multi-model over a network of federated learning? JB9898, what do you want to do? Why do you want to do that? I guess it really depends. You probably don't want to do that. I'm thinking you probably don't want to do that. You said words there. You said some words. Make a multimodal model. I'm guessing is what you mean. A multimodal model with over the network and federated learning. You don't need to do that. You don't. You probably will be perfectly fine just doing some fine tuning of an existing model. And if you want to, even if you need to, you probably even don't even do that. You don't even need to do that. Why would you be doing that? When learning a language or new data, what is your approach? Oh, Nicholas. Mostly I just jump in and start building a project. That's my approach. Before even learning the basics. I might pop open the Hello World really quick just to see how you do some of the... But you know what? For the most part, you want to build something. You just want to build something. That's the approach. Usually understand to write a copy book and then try but it took a lot of time. What's your opinion? Yeah, don't bother with the book. Just jump straight into it. Download the studio or the compiler or the runtime, whatever it is that you need to be able to build it with your language. And then start clicking on things, start typing things in and try things out. Start with a very basic tutorial like on YouTube. Start with a basic YouTube tutorial that gives you an idea of what's possible. And then you will be able to learn things quickly. That's how you do it. That's how you do it. That's the best way. And you won't waste any time. You jump right in and you learn quickly, you learn faster, and you learn better than you would ever learn any other approach. Why take the hard, slow road of reading a book and not learning very much? Why do that? Just jump straight in and learn immediately. Not only will you learn better because of trial and error, you'll be able to remember it better. You'll also make progress faster, and you'll have a lot more fun and frustration too. But that's the point. That's how you do it. You got to have that frustration, right? Negativity bias. You got to trigger your negativity bias. PyTorch RPC distributed deep learning built optimized remote procedure calls on Tensor. On Tensor. That's what it is. PyTorch. That's basically what PyTorch is. Oh, thank you for the likes, you guys. Fine tuning QLoral. Yeah, you could do that too. You could absolutely do that too. Here, let's see. Click buttons. Hi, what are your takes on DL, deep learning? Is that what you mean by deep learning? As I just jumped on without large language model. One Piece rocks. What a great anime, right? One Piece, the world's longest running anime ever and will ever be. One Piece, you got it. So what are my takes on deep learning? Good. What do you mean? It's great. I like it. That's what large language models are too. They are deep learning with some pretty great inputs and outputs on either end. Can you check my Discord message? I sent my project yet. Please once review notebook. Okay, Cromer 12. Let's check that on Discord real quick. Where did you put it? Here? Is this it? Is this it right here? Raul. Let's check. Let's check real quick. Computer vision. Oh, ooh, okay. Instance segmentation and object detection. Okay. So you've got a RCNN, recurrent convolutional neural network. Is that what that is? A faster is this? Oh, it's an IPy notebook. Okay, so you got IPy notebook. All right, let's start with this. Let's start with this one up here. 10 months ago. Let's take a peek at your IPy notebook. Let's let it running up and running here. Your IPy notebook. Well, it loads there. Let's see here. Whoa. I might have missed your chat messages. I run a little bit behind. Sorry about that. I think that's what it is. Maybe I enjoy bands kicks. Do you get less soft by talking trash? Wait, what's going on here? Correction. More human. Sure, maybe they're softies. Feel free to make fun of me. What do you get from it? So I'm running behind on some of these chat messages. What you want federated learning to save budget on hardware and combine what you have with cloud infrastructure, with some of the nodes being different kinds of models. So you want to do distributed compute if you're doing large training, like very big training. Not everyone has that kind of workload. For the most part, you can get away with doing just one big system, one like powerful compute. You don't need to do distributed workloads at this point. You don't need to distribute the workload for most projects. For most projects, you don't need to do it. Unless you're doing something like you're going to be building your own LLM or your own computer vision based on a lot of data. You won't need to. Even in that case, why not just, spend a couple of days, and have the single machine do it? Like, do you really need to have everything done for you instantaneously? Like, you could just give it a few days. Why wait? If you wanted to, but yeah, if you wanted to, that is a good use case for federated learning, basically distributed learning across a variety of hardware. Hello, recently I started using Python for my college project. Please suggest some good projects for me. Okay, Shakitis, good projects. I recommend doing a computer vision project. That's a lot of fun. But that is it. That's more advanced though. Don't get me wrong, it's more advanced. Maybe start with this right here. This is my favorite sort of getting started. It's on our Discord channel. Training a neural network on the MNIST with Keras. It's really easy. It's actually a very small. Look here. Here's the whole page. It's the entire iPy notebook right here. Very small, very short, very quick, very easy. It gets you your own all from 100% of the codes right here. You can get your own optical character recognition, computer vision, AI model. Just right here. You can get it right here. It works right there. You can absolutely get that. And it's pretty good. It's a pretty good project. If you're going to start with Python, that's the way to go. If I missed your message, I'm sorry. I'm running behind on chats. There's too many now. I can't keep up. We're past the point where I can keep up with chat messages. You're too many. You forgot to review my GitHub notebook, please. Yes. Let's check this out real quick. All right. Let's take a peek. There's a lot here. Why'd you print so much? Why'd you print out every single parameter? What are you doing? Okay, let's see here. You got what is this? Microcontroller segmentation dataset. What is this microcontroller instance segmentation dataset? What is that? What kind of dataset is that? JSON format. What is this? Let's Google what this is. I don't even know what this is. So first you should annotate. I closed it. Now I have to reopen it. Microcontroller. What was it? What? It takes so long to load. Your Pi notebook is huge. You shouldn't print. What the problem is, you printed out every single parameter. That's what the problem is. Stephen, I also made a CLI local Quinn 0.5 billion chatbot. You did? And added aliases. Now I have local free-minded mini helper in your terminal. I recommend you have one too. SAQ3000. That's kind of neat. That is pretty nifty. I want to figure out what this is. What is this? What is this? What kind of data set is this? A computer vision task that involves identifying precisely outlining individual microcontroller units in an image. Oh, at the pixel level. Interesting. So it probably is a bunch of computer boards. Is that what that is? Is a whole bunch of computer boards? Publicly available data set such found in Kaggle. And it has different microcontrollers like Arduino Nano, ESP, Raspberry Pi. These images come as instant segmentation annotations format with JSON and the Cocoa standard. I don't know what do you do with this? What do you want to do with this? I'm actually curious. Okay, what did you do? So you opened it up and then you printed it out. Well, I don't know why you did this. Look at this. This makes it really difficult to load. What? Okay. Oh, pretty. Oh, check this out. Okay, so you've got some images here. What are you doing with those images? A Python image library. Let's see. File. Let's zoom in. Let's zoom in so we can read this a little bit better. Let's zoom in so we can read a little bit better here. All right. Images. Okay. Segment annotations. Okay. So you're creating a mask. RGB. Okay. So red, green, blue, alpha. Right. The alpha, which is the opacity. Right. The opacity of the transparency is another thing. Draw mask poly something. Okay, so you've got a what do you call this? What are you doing here? Okay, so it looks like you're capturing your training data. Draw poly fill. Wait, why are you so you're drawing a rectangle? You're drawing a rectangle or a polygon? Oh, wait, polyfill. Some sort of, okay, so it would be nice to be able to see what this is. Result image, alpha compose, image convert, print, okay, show. So you've got some pictures here. All right, so far so good. Oh, Torch data loader, faster RCNN. What is this? I don't know what that is. I'm not familiar with this. A recurrent convolutional neural network all in one? Is that what that is? I don't even know what that is. RCNN model based on faster RCN towards object detection with regional proposal networks. Interesting. Okay. So it's basically object detection is what you got here. So that's what you're doing. So you're creating object detection here with Vision Transformer. Okay, looks good. Looking good. Cocoa Transformer. Okay, data set. You got your images in your directory. You're loading in the data. You're loading in all the data. Okay. For and annotate. Okay. Segments. Okay. Let's see here. I'm just walking through it. There's a lot going on. There's just a lot going on in here. And this is outside the bounds of the expectation. So I guess we're learning some stuff. We're learning some new stuff. Check the second notebook also. Okay, we'll check it also. Steven, go to Discord and run status. Oh, / stat. Quantified quantum. Is that what I think it is? All right, let's find out. / status. Here we go. Sending. You added the Discord bot. Oh no, it failed though. It failed. Hey, quantified quantum. It failed. Uh-oh, quantified quantum. LOL, ghost, Ike. Don't worry about it. What's 1 hour and 7 minutes in? I need to know because it's how long I need to bake something. Oh, is it ghost? Is it? I don't know. I'm not quite sure. Hold on a second. Everyone, I missed all your chat messages because too much happened. I was working on some fun earlier in an ESP32. Oh yeah, those microcontrollers with the tiny camera plugged into a Nintendo Switch. The idea is to automate shiny hunting. That's a good idea. Shiny hunting takes a lot of human labor, but if you can have the AI do it, might as well. That's a really good idea. Nice. Drink some water. You talk so much. I know. Hey, we're all good. We've got a diet that allows us to be successful. Steven, I also made a CLI local Quinn. Oh, wait, I already read that one. Sorry if I missed your chat message. Too much happened. Please go to the end of the notebook. Some good results of the training. Okay, we'll go to the very end. Okay, so here is a picture of, it looks like a Raspberry Pi. And did it work? Did it work? Did you find it? Did it succeed? So you've got your models. You've got your model there, your model file, faster RST. Okay. Display the image with bounding boxes. Oh, okay. So you're able to draw when you find, this is image recognition, computer vision. All right, so you built a model that is able to outline it with a rectangle when it finds an object that it is looking for. Very nice. Very nice. And it looks like it works. You showed that it works. What would be neat to see is if you could do it with multiple at once, right? Can you do multiple at once? Is it possible? I'm not sure if it is or not, but it says boxes. So get predicted bonding boxes. It looks like you have the capability to do it. It would be kind of neat to see if it was possible. Can we join your Discord, number 3? Absolutely, Nicholas. You can definitely join the Discord. Welcome on in. Join the Discord. Here, I'll click the link here. We'll click the link for the Discord. Let me click the copy button. Happy to join in. Here, at Nicholas, Nicholas. Here is the Discord link for you. There you go, Nicholas. Let's see, how much time do we have left? Okay. So we've got maybe 20 minutes. I'm not sure. Maybe 25 minutes left, and then we got to get going. Let's see here. So, if I missed any of your chat messages, just retype them. But it looks like I got to most of them. Hey, how's it going, Erwin? Welcome on in. Good to see you. All right. Let's jump back to our original task for the day. We're trying to do PyTorch. We're trying to get the basics of PyTorch, and we're trying to understand it. So we've got data sets. Let's pull this over here. Second notebook. Oh, really good. Check it out. Okay, Chroma 12. We'll check out the second notebook real quick. We'll check it out real quick. Second notebook. Here we go. Mask. So you've got the mask version. Oh, it's also a very long load. Oh, actually, it's actually pretty quick. It's a lot quicker this time. Okay, so you've got the same data as last time. Okay. You've got the image, annotation, the first image there. Okay. So you've got similar as last time. Very similar. Custom data set. Okay. Let's go down here. Root images, self-annotate images. Okay, so for ANN, artificial neural network. Is that what's going on? ANN? Boxes, torch, the tensor. Okay. Let's see. So this is the new part. You've got a mask. You've got a new mask here. Which image draws mask poly. So you're going through, you got your list comprehension happening here. Segment. This is the same code as last time. I remember this from last time. Okay, in the previous notebook. Okay, so you've got your data set. You're printing out some arrays. It looks good. So far, so good. Mask CRNN ResNet. Wow, ResNet. Some old names there. Mask CRNN. Okay, this is your model here. This is your model. Is it okay? Yeah, that's you printed the entire model. This is a pretty big model, by the way. This is a pretty big model. Wow. Do you really need this big of a model? That's a lot of model right there. Annotation file, categories. I'm actually kind of curious what your categories are. Okay. Let's scroll down to the bottom because let's see here. See what the output is. Oh, look at that. Look at that. Okay, so what do you got here? Show, display. What are we looking at? What are we even looking at? Okay. Torch Vision, you've got your image processing, request bytes, input, output, load image from URL. Okay, so it looks like you can pull in any image, that it supports any image, load the image, and then you convert the image for the input for your model, right? You need to get the data for the model. Transformer, Vision Transformer. Hey, there we go, using Vision Transformer. Did you do that in the previous one? I didn't see it. Vision Transformer to tensors. Okay, so where do you import this data? Where is this at? Find there. Wait, find exit that. RGB. Let's see here. Run status on Discord. Live stream timing, bro. 1 second. Let's see here. We can join the Discord. All right, let's try it again. Let's try the status. All right, we're going to try it one more time. Quantify quantum. Status. Here we go. Is it working? Send it to the command. Say, what's the command? Application to respond. Quantify quantum. It didn't work again. What's going on? It didn't work. Hey, the Scoobs. Welcome into our Discord. Okay, what else we got here? Confidence threshold. Adjust this value. Okay. CUDA. Oh, CUDA. So you're running on NVIDIA. You must be rich. You must be rich if you're running on NVIDIA. NVIDIA GPUs are expensive. Vision Transformer. Okay. To CUDA. Confidence threshold. Model eval. No grad. Prediction. Remember, we could use the new, what is it called? Inference mode. You could use the new inference mode. We're learning this because Chroma 12 taught us about that today. Chroma 12 taught us about inference mode. See, this is the old way to do it. You don't need to do this the old way. You can use inference mode now. Use inference mode instead. Let's see here. So that's one thing to upgrade. Filter boxes, masks. Okay, so you're going to run through and you're going to populate a whole bunch of masks and filter boxes. Though your output here isn't outlining it the same as it was in the previous one, right? Mask, filtered mask. I got to know about inference mode a few months back. Chroma 12, thank you so much for mentioning it. Yeah, this is the first time I'm learning about it too. First time I'm learning about it. Thank you. It just worked. I know, quantify quantum. Oh no, it's terrible. This is kind of neat. So it looks like I don't actually know what's happening here. Are you RS? Is this what client 1, client 2? I don't know what I'm looking at now. It's supposed to be computer. Thank you for the likes, you guys. I don't understand a lambda function. Wait, a lambda? Are you talking about lambda functions? Now, how I learn this anonymous or lambda function. Lambda functions are just, thank you for the likes, you guys. Yeah, try again. Okay, we'll try again. We will try again. Thank you for the likes, you guys. All right, so lambda function is the same as a regular function. It's just that you're defining it in line, right? So you define a function in line without you having to call on it separately. It's actually really simple. All right, here we go, quantified quantum. We're going to do, oh, wait, look, it's working for you. It's working for you. All right, / status. Here we go. Let's try it one more time. Is it going to work this time? It worked. Hey, it worked. Quantified Quantum. Look, it works. Thank you. You got ourselves. This is our very own Discord bot. Check it out. We now are official. It feels like this is like, a point of pride or, a milestone when it comes to like, hey, how well are we doing on our Discord? Oh, this is how well we're doing. We're doing so good. Quantified Quantum says it's time for a Discord bot. So we got one. This is great. Thank you. Quantified Quantum is amazing. We got it up and running, you guys. You're out. Peace. Congratulations on the bot, by the way. Thank you, SAQ2000. Network problem. Wait. What do you mean network problem? What do you mean network problem? So the scoops. What channel do we ask questions? Any channel. You can ask questions any channel. It's the scoops. Any channel works. Do you use Dvorak keyboard layout? I use just QWERTY. I use QWERTY. I've done Dvorak before. I've done Dvorak, but I stopped very quickly. I only did it for a month. I did Dvorak for a month, and it was great because, you just don't move your fingers very much. You just kind of keep them on the keyboard, and you only have to reach out. But I use QWERTY. So for now, at Nicholas, I use a QWERTY. QWERTY. I use a QWERTY keyboard. It's QW QWERTY. I use QWERTY. I jumped back to QWERTY because I used to use Dvorak, but then I found out I'm good. I'm fine with QWERTY. We're having a problem. Hey, Stephen Wolfs, how's it going? Welcome in. Happy Monday. We're doing some PyTorch. We're learning PyTorch now. And so what's up? We went through a notebook. So we went through this notebook real quick on Chroma 12's notebook to see, this was 10 months ago, right? Chroma 12, this is 10 months ago. So you created this computer vision using PyTorch and CUDA, right? So you're using CUDA, which is amazing. You've got access to some GPUs there. You got access to some GPUs, which is great. That's what we're kind of going through. That's what we're learning. We're learning things today. We're going through it. All right, let's see. Okay, so that was a lot of fun. Let's see if we can. Thank you for the likes, you guys. So that Chroma 12 looks like a really good, solid computer vision application. And it was in a Pi notebook, which you can totally do. It's completely fine. I typically like to keep everything in code directly in my editor. I like to keep it all right here so I can save it to file, and then I can piece parts out. Although it is nice. I mean, if you needed to annotate, you could just, annotate with code comments and things like that. Although with an iPi notebook, it is a lot better. It's a lot better from the ability to document inline and run the code directly and save your outputs. So iPi notebook is actually really powerful. You were able to demonstrate your computer vision application without me even having to run it, which was amazing. So that's why Pi notebooks, really good. Hey, I have a business idea. Oh, you do? You got a business idea? What is it? What do you got? But I don't even know where to start. Oh, you start by just jumping straight in. You got to start immediately. Just start by making the product ready and available. And then you start by marketing it, right? So you do marketing. You could do a business plan, though those are boring. The business plans are boring. You don't have to do a business plan, but you should do at least some basic math to make sure that it's affordable and that you don't run out of money. You got to do some basic math. All right, I'll document the bot code soon. Nice, and push it to the repo. Quantified Quantum, that sounds great. And then we'll spin up a dedicated server to have it run. We'll spin up a server so we can have it run. That's great. All right, let's see. Let's get back to the tutorial. Let's see. So we want to at least get through this introduction here. We can at least get through the introduction, and then we'll call it a day. Okay, so let's download the data. Let's copy this here. Let's copy that. All right, let's jump over here. Set paste. All right, we're going to paste it in. We're learning some stuff. Okay, so training data set, fashion MNIST, which is apparently a bunch of pictures of clothes. It's apparently a bunch of clothes. We're going to set it for train, download true. Okay. Then we got our test data, which is the same thing, although we won't train false. Oh, cool. Okay, so this is all the training data exclusive of the test data, and the test data is separate here. All right, so there we go. So I bet you if we run that, it's going to download. So let's jump into some of the chat messages you guys got here. So business, actually secure password management service. Wait, don't we have that already, Quantified Quantum? What do you mean actually secure? What do you mean by that? I'm actually kind of curious. What do you mean by actually secure? What's different? What's different? Shubha, you use Django, which is a Python ORM, right? Object Relational Model, and a template engine all in one. Django, for your backend, is it able to handle millions of users? It is if you distribute the workload, and if you also distribute the read replicas for your database layer, right? Because Django is an ORM, right? It's an object relation model. It gives you the capability of tying objects in your Python world that match the schema of your database, so you don't have to translate that as much, right? It simplifies the application layer with your data layer. It merges the two, and it makes it a lot easier. And it comes with a template rendering engine, so you could automatically render basically whatever you want. HTML. Thank you for the likes, you guys. Thank you for the likes. But if you wanted to make it scale, you just got to make sure that your database scales as well. And then you've distributed your workload across, and you're good to go. So yeah, it could absolutely go to 1 million users. Thank you for all the likes, you guys. Do you contribute to open source? Can you tell me how to run large code bases locally? So those are two different questions. You got two different questions there, Soham Joshi. So wait, let me think about that for a second. Hey, an update for you. Got an internship in a startup. You did? Wolf's, congratulations. Hey, everybody. Wolf's got an internship. That's amazing. Good job, Wolf's. You did it. You got an internship. That's actually a big challenge these days, isn't it? Getting an internship or some entry-level roles. I've been hearing that it is quite challenging these days because there's just a large pool of engineers who have many years of experience, and they are looking for jobs as well, right? They're looking for jobs too. And so it's often, I think right now, at least just for a little while, they're consuming all of the available positions. So entry-level jobs are being taken up by people who have years of experience. So you got some problems there. You got some problems. So Soham Joshi, yes, I've contributed to open source before, and not a lot, just mostly a few projects here and there. And then most of the stuff I build as well is open source. So I guess you can kind of count that. Can you tell how to large code bases locally? What do you mean? You can mostly run almost every code base that you want locally. You can almost run every code base. You probably want to use Docker though. That would probably be helpful. Soham Joshi, I guess it depends. You should see what code base you want to run. Which one is it? As in so encrypted that even you can get access to it, even if you want. Master code is only known to the user. Oh, okay. So quantified quantum, you're saying that you want to build a business that is super secure, that not even the owners of the business, right, yourself, like you, wouldn't be able to access any of the data. Only the end user would be able to access the data. Thank you for the likes, you guys. So, like for example, if you contacted support, if you're like, hey, I forgot my master code, can you help me remember my password? Support is like, nope. Sorry, we can't. It's too secure. It's so secure, we can't help you. You can't recover it. It's unrecoverable. So you could do something like that. Or you could also do something like key splitting. So quantified quantum, you might want to be able to give access to the user, to give them permissions to enable key splitting, which is a capability to also access the data unencrypted, maybe back to the master key of sorts. You can encrypt the master key using separate keys, which you distribute across different systems and different databases, and 3 parties have to have it. 3, like you can split it 5 ways, but 3 people need to access 3 out of 5 keys, right? So key splitting, that could be a good way. Engineers are like mosquitoes right now. Wait, what do you mean? What do you mean they're like mosquitoes? Because there's so many of them. That's what you mean. Yeah, you got it. There's a lot of them. There are a lot of engineers out there. Told you, bro. Soon we'll learn and we'll both work together on something cool, Wolves. Congratulations again. That's really cool. Hey, Somaya. Hi, I'm back, brother. Cool. Welcome on back. All right. Decentralized hash table. if you want, decentralized hash database, sure. I mean, if you want, wait, what do you mean, Mark Wong? What do you mean, Mark Wong? Why do you want to do a decentralized hash database? What are you trying to build? That actually sounds like a fun project. That would be a really good project, by the way, to build it. Hits the engineer, the insecticide. Yep, you got it. Yep. Like, poof. Yeah, oh, there's poof, poof, right? And then spray the insecticide. You got it. All right, let's jump back to our tutorial. If I miss any of your chat messages, let me know. We'll jump back into them. Just retype them into the chat there. Retype them if you have any of your chat messages that I missed. Okay, so we downloaded our data. Let's pop back over. Finally over here. All right, so we downloaded it, looking good. All right, we passed the data set as an argument to the data loader. This wraps the iterable over our data set. Oh, does it? Wait, did that happen? We didn't do that, did we? Data sets. Okay, so this is what we're going to be doing. We haven't done it yet. Isn't blockchain decentralized hash database in a way? Null void 12. All right, let's think about that for a second. Null void 12. Let's think about that. We need to think about that for a second. Hold on, everyone. Null void 12 made a statement about blockchain decentralized hash databases. Okay, so it is it's a decentralized, but it's a consensus algorithm. It's a decentralized consensus algorithm. All right, what that means is all the computers are running the same set of software that they can all agree upon a very specific order of operations in order to agree a transaction is valid. It's not a hash table, right? You could index it, right? So the whole point of, so that's blockchain. It's decentralized consensus algorithm, right? So you can have the software running on any of the computers anywhere in the world, and they all follow the same rules. It basically is a piece of paper that has a bunch of rules written on it that says, follow this order of operations in order to agree that transactions are legitimate. That's what that is. So that's one thing. The second thing is a hash database, or even a distributed hash database, completely separate thing. Because a hash is typically, or like a hash table, is for indexing strings, right? You want to index strings. So you could also use that in a blockchain if you wanted to look up records. If you want to look up records, you want to index them so they can be found quickly. So if you have 1 billion transactions, you want to be able to quickly look up specific transactions based on a public key. So you could use a hash database, right, to index the data, which is separate from the blockchain, right? It's separate. So you can do that as a utility. It's not included in the blockchain. It's not included in the blockchain. You could keep it separate. So there you go. I hope that described the details. I probably could have wrote this on, we probably could have diagrammed that a bit for you. We could have diagrammed it a bit. Hey, I have $1 billion business idea. Oh, okay, you got $1 billion business idea where I can make all unorganized businesses into organized way I can't disclose it. Okay, but can anyone explain to me how to get an investor? Oh, so you are doing it right now. You're advertising, right? So all you got to do is make yourself well known, right? So have you heard of AngelList? So AngelList. So check out AngelList, right? AngelList built price. You can what is it? Raising. Yeah, look, there's got to be a way here. Solutions, fund administration, investment, emerging. It's around here somewhere. Venture. Yeah. Just go to AngelList and then look for AngelList alternatives. AngelList alternatives. There you go. So you could do this as well. So check out AngelList alternative. Seed Invest, Crowd Invest, Republic, WeFunder, Angel Investments, iAngels, Our Crowd. Here you go. There you go. You're looking for investors. Start here. Start there. Get there. There you go. Start there. I think that's a good place to start. There's a whole lot of options. Oh, there's even 6 more. Wait, micro ventures. Wait, yep. You got a lot of options here. You got a lot of options, you guys. So there you go. I hope that helps you. Valstore is a native support for distributed hash tables. Okay, so Valstore, it sounds like it has the ability to hold its hash tables on multiple nodes. Very important for mega cardinality. When I say that, that means just a large number of unique items. That's what a hash table is good for, is to look up a large number of items, like billions and billions of items. So Valstore, excellent. Support for distributed hash tables. There you go. What about the algo trading? Did you use it to make money? I was expecting you to make lots of money out of it. Oh, so we wrapped up last week on Friday with the final episode of our algorithmic trading with AI because we got good results. And we made it available to you, open source, available to you as much as you want. And there was even someone who posted here. Let me see here real quick. On our Discord channel, check this out. Under free resources, right here, someone made a notebook, a Python notebook, I believe. Oh, wait, not this one. Where is it? Right here, Colab, a Google Colab. Here we go. And this uses our AI model, our Gemma Transformer Classifier, which you can profit from, and they show you exactly how to use it right here. Here you go. Someone made this. So if you want to continue from here, you can do it. The only thing that I recommend changing is this right here is the one part that needs to be changed. It's not Sleep 500. You want to fetch news items whenever you see a new news item, fresh news item. It's got to be brand new. Then you can trigger the AI model to make its recommendation. You don't want to wait and then trigger every 5 minutes because the model is trained on seeing when the news article is announced, the first time it's announced, that's when the AI model is trained. If we want to do it like this, if you want to do it at every 5 minutes, we have to retrain the model and do it differently. Or you could just, instead of doing this, just look for most recent news articles, and if anything shows up within like a minute and it's a minute old, trigger this model and then have it make a call for you. Have it make a call. There you go. That is as far as we're going to go with the agentic, or what do you call it? Algorithmic trading bot. That's as far as we're going to go. We could go further. We could actually plug it into an exchange and then have it trigger real buys and sells. Though I've done that before in the past and I've had success, and that's bad. Well, I mean, that sounds like good, right? What do you mean that's bad? It means that it takes up all of my time because it's the only thing I care about. Be careful. It becomes all consuming. So you got to be careful. You got to be really careful. And so that's why I elected not to go any further. Because it's dangerous. And I've had the problem before where I stopped eating and I stopped sleeping because that's all I cared about. So that's the problem. You guys. Oh, you're going to banish Quantified Quantum. Steven's a great stream. Always. Thank you. Keep positive and stream refresh. Cool. You will. Positivity. You got it. Are you taking questions from Twitch? Oh, we're only streaming on YouTube right now. The Scoobs. We're only on YouTube. We could eventually go to Twitch though. We haven't done it yet. True, Mr. Wolf. Okay, so if I missed any of your chat messages, I'm going to try to go through them real quick. I might have missed. What about trading algorithm? Hey, I built a thing and I told making the user Google Drive as a database storage for him. Oh, that sounds perfectly fine. You did it the right way, Wolves. Sounds good to me. Let's see here. Oh, Y Combinator. Oh, right. Y Combinator. I forgot about that one. Yes. So if you have Y Combinator is an accelerator, though. It's different. It's not just investors. It's a program. Y Combinator and other kinds of accelerators have you go in and work as a cohort, right? They have cohorts. They only take so many startups per quarter or per half year. Whatever the turnover rate is, they have you work with them directly. And they do that and they fund you. They fund you, but they also give you a whole bunch of resources on top of it to give you the best possible chance of success. They do that on purpose because it increases their investment's likelihood of succeeding. So it's a different approach. If you want to go into an accelerator, Y Combinator is one of them that you can do. You're a beginner in coding. Intra, you're a beginner in coding. Always good. The best way to become good at something is to be a beginner in something. That's how you got to do it. Coding is nothing, just a few concepts and later mastering those concepts and syntax. You got it, Wolves. So coding actually is pretty accessible, especially if you start with something like Python. You got to start with something like Python, which because it'll give you easier access to understanding how things work without the encumbrance of heavy syntax. So keep it simple and easy to get started, and you'll be able to learn more quickly and more easily without any of those encumbering and complex syntaxes. You got it. Solve programs logically and mathematically. How I want to remember the binary digits thing. Oh, why? Wait, why do you want to do that? You could just memorize the algorithm. So the binary is pretty straightforward, right? So what is it called? What is it? Excalibur. So binary is just really straightforward, right? So you've got, it's just ones and zeros, right? So you got a whole bunch of ones and zeros. Let's see here. Let's see, one. Let's see here. 8, click 1. Is that how it works? Yeah, so you got a bunch of ones and zeros. Let's zoom in on that right there. Zoom in on that. So you got 1 and 0, then you get another 0, and you just look, it's just based on digit counting, right? So it's base 2, right? Base 2. And then you're used to base 10, which is decimal, which means 10, right? 10 digits or 10 numbers. Base 1, right? So this is 3, right? This is 2, right? That equals to 2, equals 2. Let's see. 1, 0, 0 equals, I think that equals, is that equal 4, right? Because you've got 1, 2, 3, let's see. Wait, let's see here. The 0, 0, 0, 0, 1 equals 1. That's 2. And we'll go over here. We'll say 0, 1, 1 equals 3. Yep. Okay. So it's all about, I don't know how else to say it. You know, we could have just put this in our code editor. We could have just put this in our code editor, but that's based. Oh, you want to go a step further? Wait, what does 5 look like? What does 5 look like? All right, let's see if chat can get this. What is the answer? How do you get 5? What does 5 look like? Let's see, do some question marks here. Let's see. Question equals 5. What does 5 look like? How do you do 5? Let's see if anyone in chat can figure it out. Let's see if you got it. 101. You got it, Slip. You got it, Xylophone. Xylophone. You got it. 101. There we go. And then 6. Let's see, what do you got? What's going to be 6? Let's see if anyone. Oh, wait. That's binary notation. You got it. The Scoobs, you got it. Binary notation. Hey, how's it going, DWSP? Welcome on in. Happy Monday. You're hanging out. You got it. Intro, you got it. Wow, chat. You guys are smart, chat. Look at you. You know your stuff. All right, what is the maximum number possible? Right? What is the maximum number here? It's a 3-digit binary. It's 3-digit binary. So what is the absolute maximum number? 0, 0, 0 is going to equal 0, obviously, right? So this is 8. It can go up to 8. With 7, you got it. You did it. 7. And basically, it's going to be what else could it be, right? What else could this be? It's going to be 1, 1, 1. There you go. So here's binary. And then if you wanted to go bigger than 7, then you just add a digit in front. Like this, right? You add a digit in front of all the numbers. Actually, let's copy and paste. Oh, wait, can I? Yes, let's copy and paste this into a terminal window. What's 6 in gray code? What are you talking about? What's 6 in gray code? What's gray code? I don't know what that is. I'm not sure what, wait, oh, Solmayo, I've shared my LinkedIn account on your Discord under general. Okay, cool. I am in 3 years of my undergrad program of CSE and AI ML. Excellent. Please check it out. I suggest improvements. All right. You got it, guys. All right. Oh, is that the answer? What is gray code? Hello, Solo Bolo Clips. Good to see you. Welcome in and happy Monday. You're beautiful. Oh, thank you. Thank you so much. That's a compliment. You've given a compliment, and that is a very nice compliment. You gave a compliment. Appreciate it. Exhaling binary. Exhaling binary. You got it. We're exhaling binary. What is 8 in the bender over method? What? Next level, Joe. Wait, what do you mean, John? Wait, Jonah. Next level, Jonah. What? You guys are saying weird thing. Gray code. What's going on here? 8 in the bend over method. What is that? Best online courses for machine learning. If you have any suggestions, go to YouTube. If you're going to be looking for tutorials, I recommend Solo explaining binary. You got it. That's what it is. Can you be my friend? Yes, we'll be your friend. Your friend, absolutely. 421 equals 4 plus 1. 101. What's happening? 101 is going to be 5 in binary. But yeah, okay. Oh, got it. Oh, interesting. Please read my comment. Okay, 1 second. Can you be my friend? Yes. Was there another comment? You're beautiful. Yep, I read the comments. Is there any other comment there? 101. You got it. Is binary calculated through the capacitors in a computer? Capacitors. A capacitor? Capacitor. No, it's not, right? It's not. No, the capacitors are just there to enable energy bursts, right? To have consistent, it's like a mini battery. It's in order to prevent rapid change in voltage that's not expected, right? So that capacitor is just there to maintain a constant current, right? Where you have a power source that can fluctuate in its power source, and so you need these capacitors there to power your computer in a way that gives it a constant voltage, because you don't want voltages to shoot all over the place, and so that's what a capacitor is for. 1 plus 1 equals 11 in Bend-Dover method. Oh, interesting. I didn't know about that. That's kind of crazy. The comments are up. The comments are up higher. They're up higher. Sorry, let's see here. 10. All right, any higher? See here. We're scrolling on up. Are you Christian? I have already remembered in Python. So yep, you asked a religious question. We keep things focused on computer science in this channel. Computer science, you got it. I've already remembered the Python. Good to hear. All right. All right. So check out Electro Boom about the capacitors. Mark 1. Good. Excellent. Good advice. Actually, let's do that real quick. Electro Boom. Oh yeah, this guy. I remember that guy. Is that who you're referring to? He's hilarious. I love this. He does a lot of fun things with electricity and fire. He makes things turn on fire. Unintended, right? It makes things explode. This guy's great. He does all the things. He does all the things that you should not do. He does all the things that you should not try at home. Check out Electroboom. He's great. Will AI even still exist on the future? Mike Bloomberg. What do you mean, Mike Bloomberg? I think so. Why wouldn't it? Absolutely it will. Absolutely it will. You got it. It will, by far. AI absolutely will exist. By the way, Steven, make sure you're switched to live chat over top chat. Wait, that's probably why people think you're missing chats. Wait, what do you mean? Okay, so here's the chat that I see. I see the chat right here. Got it. Okay. So I probably what I could do is have a separate window open that has the chats on it. I could probably do that as well. But how can they run without electricity? That would be like a very big number water wheels. Bajillion water wheels. You need electricity. Oh, Mike Bloomberg. I see what you're saying here. You're saying that we're going to have some sort of catastrophe in the future where we can't harvest the power of the sun or any other kind of electricity gathering utilities. That sounds dangerous. How far in the future are you talking? Mike Bloomberg, how far in the future are you talking? I will appear in your dreams tonight. Okay, so sounds good, Soumya. It sounds good. All right, so let's jump back into it. So we got one last. We have to get to our tutorial here. This is like the one thing I wanted to do here on our stream here. So let's see if we can copy and paste even further. Let's go a step further. All right. Using AI produces pollution. Oh, guess what? Not a lot. Not as much as you think. So it turns out if you combine all the data centers in the world, AI and non-AI, right? Just traditional data centers, they are like not even close to even a fraction of a % of the pollution in the world. You're right, there is pollution, but if you count data centers as a factor in that, it is a rounding error. It's only a few basis points. It turns out there is a large focus on misinformation about that. It turns out you just gotta look at the data sources. You gotta see what all the energy consumptions that are occurring, and you're going to see where we're at now. It's not like transportation cars and vehicles and smog and pollution. There you go. That's a huge one. Animal farming, there's another one. So you've got transportation, which is running on combustion, right? Combustion fuels. And then you've got farming, which is also very pollutive to the environment with methane and other things like that, right? Animal farts, right? So those two things are way bigger than when it comes to data centers and AI. You're thinking about electricity, you don't really need to when it comes to computers because we're nowhere near. Even Bitcoin mining, right? You were like, oh, mining Bitcoin is so wasteful. Yeah, it is. But when you compare it to the level of pollution that we're getting from other things, it's still not even 1%. It's not even 1% of the pollution, you guys. It's not even 1%. Using AI produces pollution, but not as much. Not as much. Most people, the programmers, are saying we are going to be replaced by AI all the time. What do you think about that, Republic? What do you think about that? All right, so right now, at least the existing AI systems that we have now that are code generators that can do work for us, they're just tools. They don't have aspirations or ambitions or desires or anything along those lines, right? They don't have any of those things. You need a human to drive that. You need a human to drive it, you guys. So when it comes to AIs taking your job, that is a very short-term thing. Right now, the AIs that exist, they're just tools, right? They're tools. And what they enable people to have access to capabilities of software engineering. Here's the great part. They're creating a whole bunch of software that they're not going to be able to maintain. It's going to be a completely new world. Give it a year or two, you will see that the demand for software engineers should skyrocket because no one wants to maintain the application that they vibe coded. Nobody wants to maintain it, even if they have to vibe code it themselves and maintain it themselves. They don't want to do that. They would rather pay someone to do that. And so, you know what that means? Engineers. Yeah. Hashtag Cowparts. You got it, Solo Bowl Eclipse. What do you use to manage your prompts? The Scoobs. Wait, what do you mean? I don't manage my prompts. There's your answer. I don't manage my prompts. They will have no use for these things when the time comes. Mike Bloomberg, most of the programmers. Yep. Okay. We got that one. So TensorFlow versus PyTorch. Ooh. Abe, TensorFlow versus PyTorch. So they both give you the exact same thing. They both can achieve exactly the same thing. One is Google. Right? TensorFlow is Google. PyTorch is Facebook Meta. Right? You got PyTorch, which is up here, Facebook Meta, and then you got TensorFlow with Keras, which is Google. So Google, I would say, is the top of the game when it comes to the AI. They're number one because they created the algorithms, right? Their team are the ones that created the algorithms that made it possible for OpenAI, Anthropic, and all these other code generators, image generators, video generators to exist. So Google is out. Please check out my LinkedIn. So please suggest improvements. All right, let's do that real quick. We'll do that. But we're trying to do PyTorch today. We're trying to learn PyTorch. The Scoops, what do you mean you don't manage your prompts? Do you create new ones every time? Yeah, I do. The Scoops, I do. All right, so I always do because you always want to do something better, right? You might, if you're going to do prompts that are repeating, what I do instead is I build an AI agent. If I have something that I am going to be needing to use over and over, I'll build an AI agent. It will be a Python script that uses tool calling, function calling to an AI to do some task, right? Some sort of data task or an analysis task. And then I will save that and then use that as a script in the future. When it comes to other kinds of prompts, I always want something new every time. So I never need to remember a prompt. I never need to save it because I've already saved it in GitHub. So maybe GitHub is the answer. Maybe my answer is GitHub. All right, or check out your LinkedIn. We'll check out your LinkedIn 1 second. I saw that the new police AI, exo narrated. Wait, what is that? Exo narrated. What is the exo narrated? I saw that. What is exo narrated? What are you talking about, Mike Bloomberg? What's going on? PyTorch is better, to be honest. Their NVIDIA support for CUDA is good. Yeah, that makes sense because it's a null void 12. Yeah, it's much better. Well, I mean, right, because Google with TensorFlow they want you to use their TPUs, right? Their tensor processing units. Those the FPGAs that they built self-tuned for their framework, right? Thank you for the likes, you guys. Do you really explain the content? Do you really explain the content? As much as I can. I can as much as I can. All right, let's see here. All right, Somoyala. All right, let's see here. One second. Discord. All right, general chat. All right, LinkedIn. Here we go. LinkedIn. All right, we got our LinkedIn up here. Let's close that real quick. All right. Hey, here we go. Wait, how do we let's see here. Let's do this. Translate. Let's see. Let's make sure to say your name proper. I want to pronounce your name properly here.
Somalia.
Somalia. Is that how we say it?
Somalia.
All right, we got your name, Somalia. Here we go. Somalia. All right. Researcher, IT. We'll accept your request. We got it. We got your request. We'll send you a message. Let's see here. One second. Hello from stream. There we go. Let's do a party popper. Good. All right. We're connected. Somalia, we're connected on LinkedIn now. All right. Unified Autism AI model, 92%. Excellent. YOLO V8, got some computer vision there. Whisper, oh, we got some text to speech or speech to text. You've got speech to text, which maybe is also text to speech, right? Voice, media pipe. Wait, what is media pipe? I don't even know what that is. What is media pipe? What's media pipe? Contains everything you need to customize to deploy mobile. Really? Wait, I didn't. Cross-platform customizable machine learning for live and streaming media. Whoa. Okay. More computer vision stuff. Okay. Full stack engineer, BTech, computer science engineering, AI and ML. This is great. All right. So what you have here at the top of the screen is amazing. This tells everything you need all at the top of the screen. We don't even have to scroll down any further to know that you have these expertise or these skills, right? Very nice. This is a very good intro. Very good intro. Oh, you've also got some posts here. Let's zoom out. You got some posts there. Okay. Nice. Very nice. Successfully completed my research internship at the Artificial Intelligence and High Performance Computing Research Center. Very nice. This is great. Hey, you've got an amazing LinkedIn. Your LinkedIn profile is absolutely fantastic. Researcher, look good experience. Good experience. All right. So you've got some skills here, data skills, license, and certifications. Great. And you follow interests. Good to go. Look at that. Very good profile. Good profile on LinkedIn. Good job. Good job. Somalia. We got to remember that. Somalia. All right, Somalia. Great job. Good job with your LinkedIn. PyTorch is better. It is. I like it. Do you really... okay, what about if you had composable prompt management system for... Jeberting? What is that? Jeberting. What is Jeberting prompts? And their assets, like NPM package and inherit their Docker images. So the scoops, it really depends. So if you've got your workflow all set up and you're good to go, generating, oh, got you. Instead of gibberating. All right, that sounds good. Generating, much better. Okay. So that sounds fine. Thank you for the reactions. I know, generating versus gibberating. What's this saying? That seems fine. That seems fair. I mean, right now, the way I do it is I just always rewrite my prompt. And these machines, these AIs, they get better and better, and they change so regularly. Prompt Hub. Oh, that's a good one. That's a good one. The scoops. Excellent. Hey, Guru Teja, how's it going? Welcome on in. Happy Monday. I'm glad you exist. You motivated me to study programming. All right, the Respublica. That's great. Let's do programming. Let's do it. All right, let's jump back into our code editor, and we got to finish our tutorial, and then we wrap up our stream for the day. Here we go. Oh, we did binary. This is actually great. The binary, that was a great one. Okay, let's jump off to our tutorial here. Thank you for the likes, you guys. Will JSON format of prompt help us get accurate, better output of... Yes, it will, Mohammed. You want to be using that as much as possible. In fact, I recommend you use something called tool calling and function use because it is a JSON output that forces the model under a specific restriction of the kind of JSON that you're looking for. So you could use generic output JSON. You could use generic output JSON, though it's still not deterministic. You need to use something called function calling or tool use to give you deterministic output that'll be the right JSON format, the right JSON schema every single time. So yes, you're naming the right thing. JSON input, JSON output is a good next step rather than just regular text output, right? You want to go a step further and use function calling and tool use. There you go. Why do you mean that's a good one? Have you heard of it? The Scoobs. Wait, nope. I haven't, but I think it seems fine. What I'm saying is it seems fair. It seems like it's good. Level up your prompt management. I mean, what I meant was it seems fair. I mean, it seems fair to use a prompt management system like PromptHub, for example. You could. So, but my explanation is though, the AIs, these large language models, the code generators, they all are changing so rapidly that your prompts, they'll need to be changed anyway. So I figure might as well completely rewrite them every single time. Unless you have a very common pattern that you leverage and use, you should put that into like GitHub and make an app out of it. You could make an app out of it and be even better. Structured output always helps. Null void 12, you got it. We want deterministic output, everyone. Deterministic output. So, you are so inspiring. I can't believe that a CTO just viewed my account. You got it. You got it. We viewed your account. You got it. Somalia. You got it, Somalia. You got it. We checked it out, and you've got a really good LinkedIn. You got a great LinkedIn. Oh, nope. PromptHub is it good? I think it's fine. I'm fine with it. I don't have any issues. I don't understand how large language models, deep learning models, watched a lot of videos and tutorials, never be able to understand those concepts like neuron or layer or normalization, etc. Okay, Guru Teha. It's actually really simple. It's not as complex as they make it seem. It's really not. They use a lot of fancy words and a lot of code. Really, it's just a bunch of numbers. Think about it as a bunch of numbers. A whole bunch of floating point numbers. It's like this. It looks like this. How do we do it? Actually, we had this here. Where is it? Is it this? Nope. Was it this? Here, let's pop in over here. Here we go. I think we maybe show an example. Here you go. Right here. Look on the screen. All right. Here, see on the screen? This is what AI looks like. If you ever wanted to know what AI looks like, right here on the screen, you guys, right here. This is what AI looks like. It's just a bunch of arrays. It's a bunch of multi-dimensional arrays. That's what AI looks like, and that's what it is. They call them parameters or weights or biases, right? Which are parameters, which are basically or coefficients. How many words do we need for the word number? The word number, right? How many words? It's a number. So that's what AI is. That's what it looks like. And what we do is then we have a lot of these numbers. We stack them all together, and then we do multiplication on them, right? We do matrix multiplication where we pivot or rotate, right? We pivot the matrix, and then we do matrix multiplication. And then output from that is another matrix. And then you take that matrix, and then you multiply it again with the next matrix, and then you have it down the line. That's it. Is it more complicated than that? There's a few more details in there. Yeah, like activations and inputs and vectorizations and embedding, tokenization, a whole bunch of things. But you know what? At the end of the day, it's all numbers, you guys. It's all numbers. Don't make it seem like it's that complicated. It's really not. Oh, that's the wrong site. Oh, sorry. Prompt. Let's check out the right site. Okay. Any suggestions how to grasp these concepts? YouTube, to start at the beginning, go to YouTube and just watch videos to get some of the ideas. They're going to use a lot of terminology. They all mean the same thing, a number or a set of numbers, right? Gradient. That's an array. Gradient. What is a gradient? It's an array. What is the layer? It basically means an array, right? Which basically means a bunch of numbers. There's stochastic gradient descent. That is a really neat word, right? That basically means random array multiplication. Random array multiplication. So just practice it by going on YouTube. Just to get some of the things will be out there. I think just go focus on YouTube is a good, but also if you want to go further, if you're talking about the terminology and you want to get understanding of the terminology, I don't recommend getting to know the terminology. The terminology isn't necessarily going to be that helpful because it's just a bunch of synonyms for the same thing. What's going to be very helpful if you really want to get started is use this link here. This link here, look for training a neural network on MNIST with Keras. This is going to give you an introductory tutorial for computer vision, OCR, character recognition, right? Object character recognition. You will follow this guide. It's really simple. It's really short. See, look, it's very short. You can see 100% of it here on the screen. And it will give you the ability to run your own model. It's right there directly. And it will work perfectly fine even on a CPU, although it is a lot of data. So it might take a while, but it will work. It'll work. All these abstractions, and at a low level, it's just another pointer arithmetic. You got it, no void, you got it. Hey, how's it going, Syed? Syed, welcome on in. Good to see you. If I said your name correctly, I'm not sure about that, engineer, but you aren't. Thank you for the likes, you guys. Guru Teha, wow. The way you explained it seems really simple. Thank you very much. You're welcome. It really is. It really is that simple. It's kind of crazy how all these scientists have created all these synonyms and words that create a high barrier to entry into these disciplines. It's kind of unfair, really. I think it's unfair that they did that. They should have kept things simple and clean and easy to understand. Nope, they didn't. They created a whole bunch of fancy words that you don't need to like. You didn't even need to know. It's crazy. But yeah, you're right. Guru Teya, happy to explain it. Just a bunch of numbers. That's all it is. And that's all it is. I do recommend, definitely though, jumping in, just start trying it out yourself. Don't worry about the terminology. It'll be okay. It'll be fine. You don't need to worry about it because I can tell you, at least I did it that way. It worked out fine for me. And you know what? You'll get to do something that it'll be way more beneficial and you'll learn it better than anyone else. You get to use the technology, the most advanced technology in all human society is called negativity bias, which sounds like it's a bad thing. It's a good thing. It's your ability to recognize that something's broken. Recognize that something's broken, it's not working, and you can use that to learn. Negativity bias gives you the capability to memorize things. You can memorize things, and you'll never forget it. So why bother trying to do something simple like term memorization, which is boring and tedious, when you can go in and experience the pain and suffering that you get from negativity bias, and then you get to get the reward at the end when you finally realize that you figured it out all along and you never knew it. Keep going, man. You're great. Bye. Okay, thanks, No Void. Happy to have you here. Yatin, hey, how's it going? Welcome on in. All right, let's see. We got through a lot of the chats. If I missed your chat, just let me know. We'll jump back in. And we will read it out loud. Okay, so what do we got here? All right, so we imported our training data set, which is a bunch of fashion. It's a bunch of pictures of clothes. So we got a bunch of clothes. All right, so we got a bunch of clothes there. Let's go ahead and copy this. So we're going to do a batch size of 64. It's a pretty big batch. Let's see here. Oh, there we go. Batch size 64. Train data loader. Okay, so we've got our training data. And we got our test data. And then batch size. Okay. So data loader is going to allow, I knew data loader was going to do this. I called it earlier in the stream, before anything started. I was going to be like, we could use this for batching. We could absolutely use this for batching. Let's go ahead and open this and load it and see what happens. Okay. So we got our shape. Looks like this. Shape of X is NCHW. I guess height and width. I guess this is the number. I don't know what C is. 64 by 1 by 28 by 28. Okay, so it's a 28 by 28 image. Those are really small images, right? Am I looking at that properly? I just want to know that while building a project, do you approach it from a high level and then fill the connection links, or build everything from ground up? So you will be able to see my approach when we start our blockchain, we're gonna make our own blockchain chat. We're gonna write our own blockchain, and I'm really excited for this. I really want to do this. That's the plan. We'll probably get started on it this week. So what we're gonna do is we'll probably create a rough plan. We'll create a rough plan in a markdown file, a README markdown file. We'll create the rough plan first on what we want, because what we need to define the consensus algorithm, the way that we're going to communicate over the network. We need to define the ledger. We need to define what the ledger is. We'll probably use SQLite. We'll probably use SQLite and an unindexed SQLite maybe, or we'll figure it out. We'll figure it out later. So that's what we'll go through. We'll start out with our objective or goal. We want to recreate Bitcoin, essentially. We don't want it to be as difficult to mine, so we can define the mining difficulty. And yes, there are different consensus algorithms out there that allow us to have a more efficient approach on how to have all of the computers that are on the network together agree that a transaction is legitimate, right? That's the key. We got to agree that transaction is legitimate. And I want to do what I think I want to do is go back to the basics where Bitcoin is. Let's go back to the basics of where Bitcoin is, and we'll use hash caching. I think that's going to be our plan. We'll do some hash caching, you guys, to validate the chain of transactions. I'm really excited for it. I hope that tells you kind of my approach. All right, so let's jump back in here to all right, so we got the shapes, the outputs. Creating a model. So we're going to create a model here. Let's copy and paste it into our text editor real quick. To define a neural network in PyTorch, we create a class that inherits from the nn.module. We define the layers of the network in the init function, and specify how data will pass through the network in the forward function. To accelerate operations in the neural network, we move it to the accelerator, such as a device, right? I know this is where the device comes in. CUDA, MPS, MTIA, or XPU. If the current accelerator is available, we'll use it. Otherwise, we'll use the CPU. Excellent. Okay, so we copied and pasted this here. So we'll grab this and we'll over here paste that in. Okay, let's go ahead and close that window for a moment. All right, so we don't need this. Let's go ahead and comment that out. We don't need that anymore. Device, torch accelerator, current accelerator. Oh, I've been wanting this for so long. Right here, get the bestest I wrote my own function for this whole time. See, this is why it's really important to go through some of the documentation and learn things yourself. There is already a function that exists right here that will get you the device, your accelerator device. I was doing something different, like search agile model versus waterfall model, and then pick the development model based on your preference. Mark Wong. I see. That is your strategy for iteration, right? That is your development strategy, right? So you can do agile, which is usually 1 to 2 week sprints. And then you try to get an improvement that is in production and ready for customers to use at the end of the sprint, versus a waterfall, which you're going to have a much larger theme, right? A very big theme that is usually a 6-month cycle. And you release like once or twice a year. In a waterfall model, yep, you got it. All right, let's see. All right, so let's see. What are we doing here? All right, so this part I'm familiar with because I've done this before. So linear ReLU stack. You can name this whatever you want. You basically a neural network that's sequential. Thank you for the likes, you guys. Appreciate it. Thank you for those heart icons, the floaty heart icons right there. Appreciate your floaty heart icons showing up there on stream. We're just about to wrap up here. What we want to do is make sure that we go through this tutorial and wrap it up. Thanks, it helps a lot. And yes, these stuffs are being taught at our university. I gotta take class seriously. Thanks, Mark Wong. Good approach, Mark Wong. Thank you for the likes, you guys. All right, let's jump over here. All right, so a flat, RNN.flat. Wait, flatten, where is this? Oh, interesting. So this we're creating a flatten. I don't know what this is. I really don't. I guess it's just going to take, the input data. Oh, got it. Okay, so this is going to deal with the input data. It's going to convert it into the right shape for our actual model, which is right here. So this is our model, a sequential model, which has a bunch of dense neural networks. At input is going to be 28 by 28, it looks like. And then you're going to have a deep layer, and your output layer is 10. So this will be a classification. Interesting. Okay, so this will be a classification with 10 possibilities. So you can see here the final output layer is 10. I know that. So it's going to be 10 possible outputs, and the input will be an image in the shape of 28 by 28. Flatten means that it's going to convert a two-dimensional matrix into a one-dimensional matrix. That's what that's going to do. So a 28 by 28 is going to be, what is that? So that'll turn a 28 by 28 matrix into 28 times 28 into a 784 pixels, basically, or numbers, right? 784 numbers will be the input. So this is 784 right here. And then these are your hidden units, right? The part where the AI learns, the part where the AI remembers things, it goes there. So we flatten, and then we pass it through our model, and then we return the answer. So this is also the prediction method, right? The prediction method, which is when you create your own AI model and you want to use the model, you'll say, hey, model, here's your data. I want you to predict out of this picture, right, this photograph, is it a shirt? Is it shoes? Is it pants? Right? Because that's the idea here. And so that's what that is. So you can also use the forward using just executing it using, I think you can do model like this. I think you can put your image, your image data will go here, right? Image data here. I think you can do that as well. I'm pretty sure, but let's go ahead and print this out. Let's do this real quick. All right. Python test. Here we go. Python test. I was interviewed at some remote jobs. What's the salary that I should ask for? They generally want direct answer, but I have been telling them whatever the pay in the position is. Okay. So they want you to say what your salary expectation is. Basically, they know that you're competing for the position, right? So they need to rank you against other candidates. This is one of the problems with that answer. It's not really beneficial for you directly, but I know it's a trick. It's a trick that the employers use. It's a trick. So it's helpful to you and them at the same time. In terms of giving you the best possible salary, you want to make the number as big as possible, right? However, if your number is too big, then someone else will outbid you. Right? Someone else will come in at a better salary that has similar credentials to you, and then you will have a problem. Your problem will be that the other person will get the role instead of you. Right? Hey, how's it going, Alp 5114? Welcome on in. Good to see you here. Happy to have you, and happy Monday. We're just wrapping up here. We're about to end. We need to finish our tutorial. We're going through a PyTorch introductory tutorial, and we're going to try to see if it works. So my recommendation is, if you really want to get the role and you know that you have a lot of competition, start at the lower end. Start at the low end and say, hey, I want this job. I'm the right candidate, and I can prove it to you. And I will definitely be your person. I will happily accept the best salary, right? And then you need to figure out what that salary range is. Because if they don't post the salary range, you need to sort of do the research yourself. So it's tough. It's really tough. It really is. However, you are in a competition, right? The other people are going to compete with you. All right, so here's our model. Looks good. I completely understand this. So ReLU will be an activation layer, right? So to maintain the maximum value of each of the weights as they're being passed forward in the neural network. You want to make sure that your model doesn't get too big or too small. Although ReLU lets the numbers get really big. They just don't let them get small. That's what it is. ReLU prevents it from getting too small, but it lets it go as big as it wants. Okay, so let's see here. Optimize. All right, so it's a cross entropy loss, which means that there's going to be multiple categories of outputs, right? So let's copy this. In the optimizer, we're going to use stochastic gradient descent, which basically says it's going to randomize the data set. As it's training the models, every epoch, you'll get new data set and new format, and the batch size will be evaluated together all at once with the cross entropy loss. So let's go ahead and copy and paste that in here. Let's do that as well. All right. paste that in. So this is our loss function, which calculates the output. The output of the model will be cross entropy loss, which is going to, I guess, in a way you can kind of think of it as like averaging the outputs and then finding the delta and then averaging the output loss. I think that's kind of a way to think about it. I know it's a little bit different than that. And then the optimizer is just going to be a way to step back. It's like the back propagation. This will be the back propagation part. This does the back propagation for us. All right, so train. All right, let's train the model. Let's do it. Let's copy and paste this. All right, paste it in. Okay, let's read this. Let's read it real quick. So we got a method called train. Size. What are we using size for? Not len, but size here. Size. Oh. So it's going to be used to print the data output to see. Oh, it's going to tell us the position. How long do we have to go until we're done training? This gives us the how long we're done until we're done training. So we need to see how many training elements exist, and then we're going to run through in batches, and then we can calculate how long we have to go until it's done. So we're going to set the model to train mode. This sets the model for train mode, which enables output saving. It saves the output between each of the layers. So each of these layers has output, right? Each of these layers has output. The model will save that so that when it goes back propagation to calculate the gradients, it can calculate the gradients and then subtract the deltas to give you to update the weights, right? So we'll batch, and the batch size is 64. And then we enumerate our data loader. So this is our input is X and our output is Y. The input is X and output is Y, which is X is the same as features, right? So X equals features equals input data, right? It's the input. And then Y equals output, which outputs, which is also the targets and the labels. Set no paste. Here we go. Output is also labels, which is the answer, right? The AI's answer. It's basically the answer to the AI. What the AI thinks the answer is. And then we have our predictions, which is a full feed forward. So it's just running. I mentioned this earlier. You can directly access the forward method. So when you say this model like this, it's the same as running the forward function, which we've defined here. Where's our forward? Here you go. Here's our forward. So it's the same as running this directly on the model. You can do that directly just by calling the model and then having your inputs here. Loss, you're going to calculate the loss with your predictions and the delta, right? So your loss function, which is up here, is cross entropy loss. So basically all it does is it takes your predictions, your output, what the model thinks is the correct answer, with the actual answer, and it subtracts the two. Right? It's subtracting the two. But since there's multiple answers and the output size is 10, and we've got a batch size of 64, we need to sort of average across all of those to create a loss or the initial gradient, right? We need the initial gradient. So we got our initial gradient there. And then we run our backward, which will calculate the gradients. This will calculate all the gradients for all of our layers, which are right here. Calculates all the layers for all of our gradients. And then you run the optimizer. And the optimizer is pretty simple. All it's going to do is it's going to take the gradients, which are the losses. Hey, what is this for? Okay, scared cat. Scared cat, this is for TensorFlow, running Python, and we're kind of walking through building your own AI. Building your own AI model using Python. And that's what we're doing. So this is the training part. This is the hardest part of building your own AI model. It's the training aspect. So the loss will calculate the gradients, which is just an array. I know I'm saying these fancy words. All I mean is it's going to calculate numbers and put them in an array. That's what it's going to do. Calculate numbers and put them in an array. And then optimizer.step, it's going to take the numbers that were calculated here, and it's going to update the weights or the models, the data of the model, which looks like this, right? Where's the numbers at? Here we go. We're just going to update these numbers right here. And that's what it is. So we got some numbers, which are the gradients, which look like this is up here. And we've got our model weights, which is the intelligence or the memory of the model, which also looks like this, which is a bunch of numbers. And we're going to slowly adjust the model so that way we optimize for objective. Do they have tutorials for pop on PyTorch? Policy. Proximal policy. Wait, T3 and 5, what do you mean? What do you mean PPOS? Point of sale? Are you talking about point of sale for PyTorch? What is PPOS? Wait, proximal policies? I don't know what that is. I don't know what that is. That sounds fascinating though. Nermit. Hey, Nermit. Hey, I am working on a skin cancer detection project. Multi-class classification. That's basically what we're doing here. That's exactly what we're doing here. Exactly, except for we're using fashion. We're using fashion, you guys. We've got t-shirts and pants and shoes. That's what we're doing. So you can do the same thing. The same model can work for cancer detection, multi-class, but the results are very poor in terms of F1 score. So your F1 score is like close to 0. Is that what it is? Your F1 score is close to 0? And recall how to go about model experimentation and get the best one? Okay, I've got your answer. All right. So you need to change your input data. The model is only as good as the data. You need to collect some sort of semantic meaning. You need to be able to reduce the amount of features input. So you've got your image, right? You've got your cancer image. Not only you need to reduce the dimensionality, so shrink the image down, right? You need to potentially remove the color. The color might not be important. So you might want to go into a grayscale. So you remove the color and you move the gray, so it's a grayscale. So now you've reduced the features even further. You need to also, you could use a convolutional neural network or a vision transformer. So a vision transformer. Hey Eddie, legendary Sarb, you're late. Hey, you're doing all right. We're almost done with the stream, but we're hanging out just a little bit longer. Nermit. So at Nermit, if you're still here, try vision transformer. Try also CNN. You might have already done CNN or CNN, but also you want to make sure to reduce input features, shrink image, which you're probably already doing. Gray scale, you're probably already doing that too, maybe. You might already be doing that as well. And then do scale between 0. Make sure your inputs should be between 0 and 1. So if, say, for example, you've got your pixel is going to have a 255, you want to go, say, 0 over 255, which would be complete dark, right? And then go, or 255 over 255, which means complete white, right? Complete bright. So make sure those are the basics. Those are the basics. Now, you can go even further by changing even more about the data. So you could do something like full self-attention if you wanted to. You could change your, so if you're using a convolutional neural network, you want to change your filters. So change how your filters are working and make sure you've got enough CNNs so that way you can detect enough patterns. But you don't want too many either, because if you have too many, then you can start getting complex and you'll find features that are not relevant. So you might want to reduce the complexity of your model. There you go. That's okay. I can't be here for too long. Oh, it's late for you? Okay, Eddie Legendary. Yeah, we're about to wrap up. Do you believe AI would be able to replace financial modelers in banking? Apart from financial modeling, how else would it impact the analysis job? So today, it's already an existing tool in the human job, right? The human role for data analysis. For financial data analysis, already has the capability of leveraging these AI algorithms, right? These AI functions, it's all basically linear regression in some way as well. Could you show us how your AI model looks, please? Yes, absolutely. This is just the introductory course, because we're learning some new things today. So we're learning some new things. The big thing that I learned that was my favorite is you can automatically get your own device accelerator. There's a current accelerator function that already exists. You don't need to create your own accelerator function. It's right here. You can just use it like this. I never even knew about that. That's great. Also, there's an inference mode. There's an inference mode that exists that you can use. That's the new version, right? So Cromer 12, who was in here chat earlier, told us that you can use inference mode versus what is called no grad, right? No grad, and also model dot, what is it called? it's not train. It's the opposite of train. Eval, model.eval. So instead of doing nograd in this, you can use this. So this is the old way right here, right? So this is old, and this is new. You want to do it like this. So do it like this. This is the way to do it. So these are two things that we learned today. Really great. I think we did a really good job. I'm really happy that we did this introductory tutorial because even though we've been using PyTorch for a few years now, there's things that are new that you never used before because PyTorch is really flexible, right? It gives you the ability to also leverage it with other libraries. You could bring in your own code, which is great. The only problem is the PyTorch itself already has everything written for you. You don't need to bring in your own algorithms or other libraries. So there you go. There's the answer on that. So let's go ahead and let's comment these things out because we don't need these anymore. We're good to go there. All right. What's PyTorch? I feel like I've heard it before. Eddie Legendary, it is the world's most popular AI training framework. It's the world's most popular AI framework because it's used by OpenAI, which is ChatGPT, Anthropic, which is Claude Code, right? Facebook came out with it. It's Facebook's Meta. It's Meta's AI framework that they gave away to the world for free. It's open source, and it competes with Google TensorFlow, which is the other one. There's a whole bunch of other libraries that exist out there. PyTorch probably is number one. I think PyTorch is number one. Let's see. Just see here. Because I think things will just be difficult if the investors see strong negative fluctuations. That's something to worry about. You're right. That is definitely something to worry about. All right. Let me jump into the. Sorry if I miss your chat message. Just let me know. We're trying to wrap up here. We got to get going. All right. So let's test. So we trained we could train it, but we should also test it. So let's run through the test code really quick. All right. Set paste. We need to paste it. There we go. Paste it in. So thank you for the likes, you guys. Appreciate it. Mike Coxlong. All right, Cyber Potato 123. I see what you did there. Cyber Potato. I should have known. I'm also thinking at live stream like this, maybe for tomorrow. That sounds like a good idea. That sounds like a great idea. You should do it. You should absolutely do it. Make it possible. Can you use Python to code a Raspberry Pi? Yes, you can. In fact, you should. You should be using Python. Cyber Potato 123. You got me. You did got me. You got me good. All right. So we got our test here. So let's actually use UFC 322 prediction. What? I mean, basically, it's what we're doing. All right. So let's train and be done. All right. So this is it right here. We can train and be done. And then we can, let's see what happens. Let's see. Set paste. Here we go. All right. Paste it in. 5 epochs. All right. Print test done. All right. So this should be it. Let's run it. Python go. Oh, invalid tint test. FX. Wait. G. Here we go. Let's fix that. I know where that is. I know what we did wrong. Where is that? X equals. Here we go. There we go. All right. Boom. All right. Oh, it's running. Okay. Oh, it's running really fast. Hey, it's doing pretty good. Okay. That's pretty decent. We did some pretty decent stuff here. Excellent. Look at that. Hey, we did it. 64% accuracy. That is not good. That is not a great accuracy. That is a very low F1 score. Though I think it's actually pretty decent that we went through the tutorial today. I think we did a pretty good job. I've been trying my experimentation with pre-trained convolutional neural network models for now ResNet and MobiNet with no augmentation and have got balanced accuracy of 51%. That is really not good. Nermit 0.51 is not good. That's like basically 50%. That is terrible. There aren't any research papers for clinical images available. So if you go to Kaggle and get some cancer, let's see if we can get some data on Kaggle. So let's see here. You might already be doing this. Kaggle datasets. go to Kaggle datasets and look for melanoma, maybe you can pronounce, let me see, melanoma. Look for melanoma. Skin cancer, right? Melanoma detection with PyTorch. Is this a data set, right? We want the data sets. We just want the data sets. Here we go. Melanoma, here we go. Melanoma detection data set. Perfect. Here we go. So we got some images here. I saw them. Where'd they go? Here we go. Excellent. Okay. So see here on the screen, we've got a picture. All right. What you need to do is process this. You need to pre-process it. Let's see. Mint BCS, everything under 2 gigabyte RAM will be difficult. Torva, wait, hold on. You are such a nice person. For a person with such level of knowledge, you have no ego. All right, thank you for saying. That's really great. That's a fantastic feedback. That's a wonderful compliment. Thank you. Thank you so much. I'm happy to help. Here's the deal. Computer technology is so amazing. There's so many cool things we can do with it. We're nowhere near done. We've got so many advancements to make, and the existing AIs today that we think are magic, right? ChatGPT, we think is magic. We're just at the beginning. There's so much more to do. You think that you're cooked. You might think that we're cooked, and we were like, oh no, the AI is going to take our job. That's good. That's way off. That's a while away. Maybe 2 years. We'll have AGI. That's what the prediction was, right? 2028 and 2028. Though there's still the need to have engineering. We still need a lot of engineering. Sure, writing code might be, the computer is going to take care of that for you. You still need to engineer. How long does it take to get as proficient as you from the beginner? Cipher zone. You just practice every day. Try building stuff. In fact, there are many people who are way better than me that can do things, and they are proficient. And it's really just about practicing every single day. And you can get as proficient as me even in a few months. It only takes a few months. It really does. And then everything kind of starts clicking into place. And then you get this, it's like a steamroll effect. It's a snowball effect, right? As you start with a small snowball and it gets bigger and bigger and bigger, and then suddenly everything's really easy. It gets a lot easier. It's difficult at the beginning, and that's the hard part. How much do you earn from YouTube? Not very much yet, but maybe in the future we'll earn more. But we do earn some money. We do earn a little bit. We do earn just a smidgen. Should augmentation be data specific or model specific? You can always augment your data. So that's actually another thing to do. All right, so you should always get your data in the right shape. And then you can even augment your data, right? You could augment your data by rotating this. So you could rotate this picture, right? Rotate it by 1 degree, and then you get another data sample. Rotate it again by 5 degrees, right? Rotate it by 5 degrees and create synthetic data, right? There's another thing. Synthetic data generation right? Synthetic data generation, right? You want to rotate the image and use that as input to your model. So there you go. Use it so you can rotate the image, right? And that becomes more data set. You can also shrink and contract the image a bit. So that gives your model more data to learn from. There you go. We're learning all sorts of fun things today. All right, let's see if we can wrap up here. I think we might have done that. I think we wrapped it up. I think we did a good job here. Hey, the Tech Man, good to see you. Happy Monday. We're just wrapping up stream. You came right here at the very end. All right, let's see if we can see if there's anything left here. What are you teaching? We went through basically PyTorch. So over the last 2 weeks, we've been doing algorithmic trading AI with PyTorch in a transformer and a GEM embedding 300 million parameter model. We did a good job. We got over 80% accuracy. Which is amazing, especially because we're training on data that it's never seen before. I thought it was phenomenal. And we can optimize it so much further. We can get it going way further. I wanted to go back to the basics because we missed some things. Damn, I know, right? It's amazing. We did a really good job. And so today we learned 2 new things. We learned how to get the device, which is the hardware accelerator, the GPU, the TPU, whatever it is, PyTorch, It already has the method built right in. We never knew that. And then the other thing is Chromer 12. Thank you for the likes, you guys. Taught us that there's this new inference mode that you can use instead of no-grad and model eval. You don't need to use these anymore because these are old, right? So these are the old, right? These are the old here, right here. These are old, and this is new. This is the new one right here. Right here is the new one. Let's see. Your location, Seattle. I'm in Seattle, Joel. George, I'm in Seattle. What are the general tools for programming? Tell me, tell me everything starting from terminal code, editor, browser, etc. Everything. So you've got your integrated developer environment, which is going to be whatever your editor is going to be. I use Vim and Tmux if you want. Okay, so I'll just tell you. This is the only things I use. Here we go. Vim plus Tmux. There you go. There you go. Vim plus Tmux. And I use it for everything. I use it for AI, for mobile development, for web development, for data science. Everything you see here, it's all right here, all in the terminal, all right there. Also, I use Ghosty. Oh, here you go. GHOS Ghost-T with 2 T's. It's got 2 T's in it. Start from Google Colab. Okay, Mark Wong. Yes. Okay, so Mark Wong is saying something very important here. I'm using something that's rather advanced, and it has a barrier to entry on learning because you have to learn special keystrokes in order to navigate. However, Mark Wong, thank you. Google Colab is a much easier entry point. It's so much easier. Notepad++, you got it. Notepad++. I remember that. That's actually that was my first code editor with syntax highlighting. I remember Notepad++. I remember that from so long ago. It was great. It was amazing, and it still is amazing. In fact, it loads faster than any other IDE, other than maybe Vim, for example, right? Thank you so much. Yeah, Nermit, you got it. You got it, Nermit. Happy to help. All right, you guys, I think I'll be trying tomorrow. Excellent. Google Colab, you got it. It's the way to go. All right, let's see if there's anything left in this tutorial, and then we're going to wrap up here. So I see here, did we do this part? DS train info load. Oh, this is saving and loading the model. We don't need, this is TensorFlow. We're on the wrong tutorial. Okay, so saving and loading the model. We could do that if we wanted to. Then we can load it directly, and only the weights. All keys match successfully. Classes. Okay, let's do this. Let's grab this last bit of code here. Let's do the last bit of code here, and we'll run it last time, and then we're done. And then we'll call it a day. Set paste. Here we go. Go to the bottom of the screen, paste it in, save, and then we'll run it one last time. Oh, GG ///.new. Where's that? Okay, let's close that. Rerun it. Boom. There we go. Good night, man. The tech man. Good to see you. We'll be back tomorrow as well. Steven, did you check Quinn Family out? The SAQ. You're back. SAQ 3000. I've definitely checked out the Quinn models. Yes, they're really good. They are very good. They're right. They're from China. They're from China, you guys. Support Asia. If you want to support Asia, those are models to support. You'll be bound to time tomorrow. You will? Okay, cool. Sounds good. How many hours do you work every day? It depends, right? So I wake up at 5, and then I work until about 12. We do about 12 hours. About 12 hours every day, you guys. About 12 hours. And then we take a break on the weekend. All right. Our ankle boot, actual ankle boot. Hey, sweet. It worked. So it got the picture, which is an ankle boot, right? The picture you see here at the bottom of the screen. It predicted one. Why did it only do one? It only did one. So let's do more. Let's do more than one. How do you wake up at 5? Oh, because it's currently 2 p.m. I'm in the United States. I'm in Seattle, so it's in the afternoon for me. All right, this is the last thing we're gonna do. We're gonna test out this. So we want. Let's do this. Let's do multiple of these. I want to see more than one. So let's see. No, got actual predicted classes. Yep. Okay. So then we could do a for in. Let's see. Len test. Let's see. Okay. This right here. Oh, no. This. We'll do that. Actually, you know what? We'll just do 10. We'll just do 10. Okay. There we go. We'll just do 10 of them. I want to do 10. All right. Then we'll pop that over. Here we go. Indent. A little bit of indentation there. And then we'll set X equal to this. And this will be I, right? We'll do I here. There we go. Now we can predict multiple things. Let's see if it works. Wait, X to device. Wait, what is the problem? Inconsistent use of tabs. Oh, hold on. I know what it is. Set no paste. There we go. Boom. All right. Now we should be good. Okay. It's 2:30 at night here. Okay. It's pretty late there. Oh, Awadam, 10:57 p.m. there. Yeah, you guys, it's late. It's late where you are. It's really early where I am. Oh no, I messed up. Where's the problem? That should work perfectly fine. Why didn't it work? Maybe there's too many data sets. Hold on. Let's see here. Image, target. Wait, where is it? We'll figure this out. And then we got to get going. I have no idea about coding. Like, I only know what is command prompt and Google Colab, etc. Joel George. Okay. Let's see. Very basic idea. How do I set it worth watching you live sessions? That sounds like it's a good thing. I think it sounds like, how do I something is it worth watching your live sessions? I don't know. Wait, what do you mean, Joel George? What do you mean? How's it going, Hasbro? Hasbro FN, how's it going? Welcome in. Joel George, Google Colab. Yes, Google Colab is going to be a really good starting point. How's it going, Hasbro FN? I try hard. How's it going? For the life of me, struggling so much with indentation in BIM, it can be a challenge sometimes. It can be. Do you have any suggestions? Joel George. So start with this. Yes, I do. All right, so I posted this here. If you really want to get started with programming in general, I recommend this link that we have here on our Discord. Join our Discord channel. Here we go. Right here. The 1 hour introduction to Python. This is a really good beginner's guide. It's going to be everything you need. It's going to be excellent. It's a really good with Mosh. This is with Mosh, right? Mosh on YouTube. What is standard query language? It's a domain-specific language, ideal for mostly data science, but also for object relation management systems. You can query data in a database using a standard query language, which is just SQL, right? And you select data, and then you can filter data, and you can aggregate data. That's all SQL is. It lets you read data from a database in the shape that you want it to be read in. It gives you the view that you want. What kind of data do you want? You want a very specific kind of data? SQL is the way to go. Hey, what's up with the crown icon beside me? Anyone? Wait, the crown. Oh, is it the PyTorch? Is it the PyTorch logo right here? This is the PyTorch logo. We got the PyTorch logo. Is that what you're talking about? Is this SQL you're teaching? Oh, no, we're doing PyTorch. Structured, not standard. Oh, structured query language. Oh, it's a structured query. I've always been calling it standard query language. That's what SQL. Okay, so structured query language. That makes a lot more sense. Right? SQL, structured query language. Here we go. Structured query language. Structured query language is a domain DSL. I got that part right. It's a DSL. Domain-specific language used for managing and manipulating data in a relational database management system, RDBMS. It's pronounced SQL. There you go. And it could also be used for data science. You guys can be used for data science. What makes you use Vim instead of VS Code? I love Vim, and it's my favorite. Here's the deal. John Pedersen, use the IDE that makes you happy. There you go. That's the answer. Use the IDE that makes you happiest. And that's when you want to pick which IDE to use, just pick the one that makes you the most happy. What do I learn? So Mark Zuckerberg offers me more than $100 million contract. You will want to learn as much AI and computer science as you can get your hands on, Hasbro. That's a lot. That is a lot. You might need to learn quite a bit. Lingual Initially, this was called Structured English Query Language. Oh, it was? Really? I had no idea. SQL, Structured English Query Language. SEQL. That's why it's pronounced SQL. Interesting. The more you guys know, the more you know. Initially, it was called Structured English Query Language. That's crazy. I had no idea. Okay, so we're basically wrapped up. Oh, wait, we got to do one last thing. We got to fix this, and then we got to get going because I got things to do, you guys. I got things to take care of today. What do you mean by AI and coding? Go more in depth. Hasbro. Oh, so here is a good starting point. This is TensorFlow and Keras. Though if you want Mark Zuckerberg, you want to use PyTorch. So that's what we're doing right now. We're doing the Mark Zuckerberg approach, which is PyTorch. We're using PyTorch. See right here? See here on the screen, we got PyTorch right here. It's like this. I'll blink it on the screens, right? PyTorch right here, PyTorch. You see PyTorch? That's the Mark Zuckerberg version. If you want the Google version, you can use TensorFlow. And these are really good places to start. Start there. They're going to be hard. It's going to be challenging. You don't know what's going on. That's okay. You're in the right spot. You're in the difficult zone. Do you listen to Pink Floyd, and is it a big deal in America? I'm just curious. Yep, definitely. Some Pink Floyd. You got it. Pink Floyd, definitely in America too. Absolutely. I haven't listened to it recently, and it's been a while. Maybe quite a few years, actually. Maybe more than 5 years. So let's see if we can wrap this up real quick. So I got to get going, you guys. I got to get going, but let me finish this really quick. All right, so X. Okay, so it looks like our iterations in a problem. Only the one element tensors can be converted to Python scalars. What? Oh. Wait, no, that should be. Wait, actually, you know what? Let's just do this. Range 10. There we go. Let's do range. Let's just do this. I've got a better idea. Range 10. Perfect. Let's see if that works. We're going to see if that works. We'll figure it out. KNN. Been learning KNN and decision trees. Thank you for the likes, you guys. In Scikit learned today. Fun stuff. Shogun C. That sounds like a really fun, that sounds like a lot of fun project. Thank you for the likes, you guys. Excellent KNN. So nearest neighbor. Is that what it is? K nearest neighbor. Is that what that is about? Shout out to Hugging Face. That's the site to get me in AI. Excellent, Mark Wong. It's a lot of really good. It's the one that got you into AI. Excellent. Hugging Face didn't even exist when I started learning AI. Hugging Face is new to me. It's like brand new. Thank you for all the likes, you guys. We're going to have to get going here pretty soon. You've been to New York twice. Very nice. New York's actually a lot of energy there. I love New York. We got to get going here pretty soon. Well, you might not be able to answer this right now, but what do you think about the threat of AI poisoning? So the good news is, Torva, we can collect that data up front, and we can parse through the data, and we can clean the data. So AI poisoning isn't really a problem anymore. We've already got that solved. We already solved AI poisoning. For the most part, we're good to go. You've been messing around with Python. Next Gen Estates, how's it going, Next Gen Estates? For a while now, I'm currently trying to fine-tune Llama 3 for prompt generation with help from AI for the coding part. Very nice. Very nice, Next Gen Estate. That sounds like a great project. It's me liking the stream, by the way. Oh, thank you for liking the stream, Hasbro. Appreciate it. I see your heart icon showing up there on the screen. Appreciate it. Love the energy and the responses. Happy to help, John Peterson. Happy to help. I feel we are worried not knowing how to program. What would you suggest? Oh, Next Gen Estates? If you want to get started, the best place to start is by building a project and just set out a task. Get ready, set out a task, and you're ready to go. Build something like a calculator. That's like a really good introductory app, right? Or a to-do list app. Those are like the two best introductory apps. I do have to get going, you guys. We got our thing. Thank you for all the likes. Appreciate it. We ran out of time. So we did it. We did the tutorial. We learned a lot today. We got through a lot of things. Dude, I love seeing those shirts pop up when you're live. Oh, the shorts. Yeah, there you go. That's where we're at. We're there right now. You got it. Thank you for all the likes, you guys. Hey, Steven, have you worked at a lead software developer at Microsoft? Hey, you've been reading some LinkedIns, haven't you? You've been reading some LinkedIns. Steven, let's see here. Yes. So, yep, you keep asking. All right. So, what do you mean PyTorch? Do you learn PyTorch and then what? Oh, then you can build artificial intelligence. And then you can build your own AI and can do whatever you want. There you go. Could you explain in detail? All right. So, we got to get going, you guys. Thank you so much for hanging out today. You're basically asking, what is the future? Yes, there is a chance for that. But coding is basically the understanding of complex networks. Oh, there you go. Torva Messor. Very eloquently said. Very nice. All right. Correlations, and stuff like that. Yeah, pretty much. Yeah, you're basically creating a system that is able to process data and then give you liked the way you teach. Cool. Great to hear. Thank you. All right. Thank you, everyone, for hanging out today. We're going to get going. We'll be back tomorrow. We'll likely be starting we'll resume our assembly tutorials. We'll be doing more assembly language. Have you deployed AI on edge hardware? Soda, yes, I have. In fact, I might have even pioneered it. I started doing that many years ago. I've deployed on edge hardware before. I've done it. Yeah. That's something I've done before. I even almost created a patent. I probably should have. I can't believe I didn't. I have some patents though. So I've got plenty of patents. We're good. We're good. Even Lingual Lifters is looking at my LinkedIn right now. Lingual Lifters is seeing the LinkedIn, and yep, we got our patents there. Thank you everyone for hanging out. We'll be back tomorrow. I'm going to click the stop stream button now. We got to get going. It was great to hang out with you today. We'll be back tomorrow. We'll probably be doing assembly, or we'll be starting our blockchain from scratch. We'll create our own Bitcoin. We'll create our own cryptocurrency, and we're going to be doing it with Rust. We'll be doing it with Rust. So that's also the plan. We'll be doing one of those two things. Thank you guys, which is why, yes, there are a chance for AI replacing devs, but it requires an extreme amount of hardware if ever it is supposed to reach an appropriate level. You got it. You got it. I have some QDs. Okay. Thank you. Thank you so much, everyone. We're headed out. We'll be back tomorrow. Yep. We're in stream now. Goodbye, everyone. See you next time. Bye. Or wait, it's not stopped. I thought I stopped it. I didn't stop it. Hold on. All right. All right, here we go. Stop. All right.